mobile communication, mobile adopted growth. How many are from security background? How many of you are working on security? I think almost all of us have studied a course like a cryptography, correct? Maybe a network security. So whatever you see. So have you studied cryptography first? Cryptography first time, no? The security is. So what about because this topic requires little bit of a cryptography background. So we need to know what exactly is cryptography, what are the different concepts that we come across in the cryptography. Right. So anyhow, so if you see the whole presentation, so the topic for the today's presentation or this session is Internet of Things security. I'll- so- Hello. Okay, fine. Yeah. So in self volume card. Hello. Okay. So in yesterday's session, they might have discussed IoT, IoT architecture, IoT applications, and so on. Of it. Okay. Now, how do you define IoT? What is the definition of Internet of Things? Okay. So here, a very simple definition is IoT is a network of objects, network of things. But that much is not sufficient. They should able to communicate. They should able to exchange the data. Fine. So, like for example, take like we come across lights which are with the sensors. I hope maybe in many places when somebody enters a particular corridor, automatically the light will be turned on. Fine. And that light may be on for some time, and after that the light will be automatically shut down. Here it is. So that is mainly to save the energy and also such devices. For example, if you come to our institute, almost all corridors are connected with such lights only. Now my question is whether this I can call it as the Internet of Things. I hope you understood the scenario. Scenario is on a corridor, we fixed one light. Fine. And that light is with a sensor. And that sensor will sense the presence of any human being in that particular area. If somebody is present in that particular area, the light will be automatically turned on. And maybe that device will be on for some time and automatically it will be turned off. Now my question is whether this can be called as a IoT. Why? There is no? Okay. So here the main requirement in the case of IoT environment is we wanted to control that device remotely. Fine. So for example, like some light is on, and if you are controlling that light by sitting in your office by using your smartphone, fine, you are turning on that light or maybe a AC, maybe a fan, fine. So when you left to your office, you realized that okay, your light is on, and you need not to come to your house again to switch off the light. Imagine that light, if you are operating with the help of your smartphone, fine, some app you will turn on, and with that app you will switch off that particular device. So this is called as a IoT here. Fine. IoT does not mean a device which fitted with some sensors here, but they should able to communicate. So communication is very important. So that's why IoT, Internet of Things. Internet, that means they should able to communicate, they should able to exchange the data. Say then only we used to call it is as a IoT environment. Here it is. Fine. Okay. So here the content for this today's presentation, as you can see here, first is an overview of IoT, which yesterday's session might have been covered in detail. A very quick recap of what exactly is a IoT, fine, what is the meaning of a security in the case of IoT, and what are the IoT challenges here it is, or the issues. Second one is a security aspects. So here, so mainly we are talking about 3 points. One is security aspects of IoT. Other one is research aspects of IoT, because here there are many faculties, many students. Maybe they wanted to get an idea from this particular session, like what way this may help me to fix my problem statement for my research work, or maybe for my major project, and so on. Here it is. So that way the very important other point which I will be covering here, it is the research aspects of IoT. So where you will see like what kind of different attacks are possible in the case of IoT environment, what kind of mitigation solutions are possible for these different kinds of attacks. So that we are going to talk about in point number 4. And the last one is a research problem. What are the different solutions are available to deal with these IoT security problems, and what are the further challenges here it is. Which one of them you can take it like your research work here it is. In case if you are interested to work in IoT, or if you are interested to work in networking and all here. So that way here the main point which I will be talking about is security aspects of IoT, the research aspects of a security of IoTs, and last the research problems. Here research problems, our focus is the security only. So research problem does not mean that it is everything else.
So the research problem particularly I'll be pointing on the security aspects of IoT only here. Okay, let us start with a very quick overview of IoT. Fine, as somebody already answered, so IoT is nothing but it is a network of objects or things which are able to communicate, which are able to exchange the information. That is a very simple meaning of IoT here it is. So here, this figure actually indicates what are the different devices or objects which can be a part of your IoT system here. As you can see in this diagram, everything. So here bulb, for example. Fine. So bulb can also be a part of your IoT system. Your speakers, your vehicle, your house, your car, your television, everything, anything you assume which is surrounding to us. So it can also be a part of your IoT here it is. So that way what happened? So it is like a evergreen branch of your CSC here it is. Internet of Things is evergreen. There is an endless here it is. It's not like one fine day it will be saturated, because day by day we are coming across a new electronics devices, and people they want to connect each and every devices to the internet here it is. So that it is a evergreen kind of a branch here it is. Okay, so here it is a nothing but a network of objects, network of things which are capable to communicate or exchange the information. Now what do you mean by a security? Here many are new to the security background. Fine. So security in case of IoT is nothing but it is, as you can see here, preserving the privacy, confidentiality, ensure the security of the user infrastructure. This is like a very complicated definition which you may come across in many textbooks or many online materials and all. In a very simple way, so the security, like IoT infrastructure or IoT network does not mean only the device. So there are many things are involved. There are many things are involved in the case of IoT network or in the case of IoT infrastructure. And the security means connecting to everything here it is. For example, if I see the IoT infrastructure, so there is a IoT device. Fine. So IoT device for further communication with maybe other part of a system. So we need to have a communication network, so that way the internet will come. And this IoT is used to produce a lot of data here it is. Fine. So for example, if you are using, for example, for the remote, your patient monitoring system, very simple example, a very simple application, a remote patient monitoring system here it is. So that means in one room, there is one patient, and the patient is connected by so many sensors. There is patient connected by so many sensors. Now what is the purpose of connecting so many sensors to that particular patient? Because we wanted to sense some vitals which can be further processed to take some decision, whether the patient is in a good condition, whether the patient is in a bad condition, what kind of a treatment we need to provide to that particular patient in case of any emergencies. So all these decisions we can take by using the sensed data through these sensors here it is. So that way what happened, patient is placed in one place, and the processing of the data which is sensed by these sensors, that will take place in another place here it is. So that way between this place to this place, there is a need of a connectivity here it is. Fine. So that way here IoT does not mean just a device. So there are so many entities will come into the picture for the successful IoT communication here. So that way the security here deals with everything here it is. Security deals with IoT. For example, if I fixed one CCTV camera to my cabin, for example, the protection of that CCTV camera is also part of a security. That is something called a physical protection of that CCTVs. Because many times, so whenever some robbery takes place in the ATM machine and all, so the robbers main target is the CCTV camera only. First they will spoil the CCTV camera. So now the first question will come, how you protect that CCTV camera here? So if you don't protect them properly, then you will not get any data, and you cannot figure out who did that particular unhealthy activity here it is. I hope you are getting it. The physical protection of the CCTV camera, physical protection of some speakers, for example, they are also part of a security here it is. Now some sensor is sensing the data and sending to the doctor side, for example. Now during the communication time, now your data flows through the network. So when it goes through a network, there are so many security issues will come in the picture here. So security here does not mean just your device or object here it is. So there are so many entities comes into the picture which help us to successfully establish a communication here. So it deals with everything here it is. So if you see this definition, there are some complicated terms you may see here. Preserving the privacy, confidentiality. What do you mean by confidentiality here? Now these are some of the terms that we come across in security or in the cryptography here it is. And our whole presentation uses these terms only here it is. What do you mean by confidentiality? So confidentiality is nothing but you're hiding. Fine. So you want to send the good to your friend, and the confidentiality means good is represented something like a hash 1234, for example. Fine. So that is achieved through something called encryption. Maybe you are familiar with the term called encoding. So encoding is nothing but converting your normal text or a data into like a encrypted form, in the coded form, which will be very difficult for any person, even though he capture it, it is very difficult for him to understand what is the meaning of it. So confidentiality is nothing but you are hiding the information here it is, which we usually do it with the help of something called encryption and the decryption. Encryption is encoding at the sender side, and the decryption is nothing but the decoding at the receiver side. Fine. So the hiding the information. For example, you are sending some patient data through the network to the doctor, for example. Now it may so happen that we don't want to disclose that information. Fine, whether the patient is having COVID virus or the patient is having something else. So we don't want to disclose that information. In that case, that data has to be protected. So the data has to be transmitted in the protected form so that only the doctor can decode it. Fine, if the data you are sending in the plain text form without using this confidentiality, then anyone can capture that particular data and anyone can start blackmailing that patient. I know you are having so and so problem. No, if you give 1,000 rupees, I will not say to anyone here it is. No, there are many possibilities here it is. So that way what happened, the confidentiality used to be the backbone of your security, where we are actually hiding the data here it is. So preserving the privacy, So the point here it is, we don't want to disclose the data so easily here it is. Fine. So your cabin, fine. You don't want to allow any third party to enter. Fine. So your lunch time. So you are opened your lunch box and you started eating. So that time you don't want any disturbance here it is. So this is other concept that we come across in the case of security. Ensure the security of our users, infrastructure, data and the devices of the IoTs, and guarantee that the availability of the service is offered to everyone here. So all time, like if you are connected your CCTV camera, college CCTV camera to the network, and somebody from outside the college wants to access it, so we wanted to see that all the time the CCTV camera should work here. Fine, it cannot so happen that for some time the CCTV, like even if a net, for example, if a Gmail won't work for 5 minutes also, then people will start migrating to some other services. Whenever Gmail is providing a service, its first requirement is service should be available all the time to the customer here it is. So that way the CCTVs, or if any IoT device, if it is a part of your system, then we want to see that they are always accessible here it is. Okay, what are the main issues in the case of IoTs? Now here you may say that, so this security or a cryptography is like a well-known terms, and it is already there in case of our computers, laptop, which are a part of a network. Then why like we need to separately deal with this security for the IoTs here it is. So in the case of IoT, the main challenge here it is, or the main issue in the case of IoT is, it's a limited processing power, limited memories, everything is limited because they are tiny devices. They are not like a dedicated laptop, or they are not like a dedicated desktops. Fine, they are like a very tiny devices which comes with a limited processing power, limited memory and so on here. So that used to be the main hurdles. That used to be the main problem in the case of IoTs, because I cannot end up into a CCTV camera which is like a big box type, where I fix high-end motherboard and other things here, which is not acceptable here. Fine. So IoT devices are like a tiny devices with a limited many things here it is, and that used to be the major problem in the case of IoTs. Otherwise, what happened? No, we need not to study the security of IoT separately here it is. So security, it is already there in computers, in laptops and all. So that we can straightforward use it in the case of IoT devices. But they are not straightforward compatible, because IoT is something different than your normal desktops or your normal laptops. Because in the normal desktop and the normal laptop, as such we say that there is no resource side, there is no issue. Resource side, it's a processing power side or it's a memory side, there is no issue at all in the case of a normal desktop or a laptop. But IoT, there are so many limitations. So that way what happened, whatever algorithms we usually come across for a laptop or a desktop, they cannot straightforward use it for IoT CRS. We have to end up into a small scale cryptographic algorithm so that we can provide a very high security to your IoT devices CRS. Okay, so this maybe in the yesterday's presentation you might have seen the different applications of IoTs. Fine. IoTs, they just not limited to any educational institute. IoTs nowadays we come across everywhere here. IoT industries are there, IoTs are used in the agricultural, IoTs are used in the healthcare. Fine. You name any area. So definitely you will come across IoT here it is. So that way you can see here in factories, IoTs are used. In ships, airplanes, trains, we use IoTs. IoTs are also used in the case of shops, airports. Fine. So in the case of IoT enabled mobile device. So anyone can give an example for this IoT enabled mobile devices? Nowadays in mobile also we come across an app, no, which you can turn on when you start your walking, and it will keep a track of how many steps you walked, what is your heart rate, what is your pulse rate. So there are so many apps are available. So they are indirectly is nothing but your IoT kind of a thing only. So otherwise you have to wear the dedicated watches. So IoT enabled watches are available in the market. So if you wear that, so it will keep a track of your heart rate and so many other things here it is. So similarly, what happened in the mobiles also we come across many apps nowadays which takes care of your health related things here it is. Similarly, many apps are available which the industry people can also use it. So that way the mobile devices that what we are using for our day-to-day communication, so they can also be a part of indirectly the IoT here it is. So that way you can see IoT enabled home, buildings. Fine. Now this is all common here it is. So that way we come across a smart city project. So smart city project is possible only with the help of IoTs only here it is. So smart city project means you want to control everything remotely, nice management and other things. Fine. So this is all possible because of the IoTs only here. Anyhow, so these are some of the applications which you can point with respect to the IoTs here it is. Okay, I think this also they might have discussed in the yesterday's class, the architecture of IoTs, how exactly these objects or your things, they form a network here it is. Fine. So usually the IoTs, for example, you take your campus itself. Imagine that if I fix some CCTV camera in some corridors. Fine. Now this CCTV camera need to be connected through something called a gateways to the network. So I cannot directly connect CCTV camera to the network, even though it may look for us, okay, they are directly connected, but they are usually connected through some additional devices which are a part of a network which we call as a gateways. Through the gateways, we connect these IoT devices, your CCTV camera to the internet. Fine. And from the internet, it will be connected to the back-end high-end system where the processing of these data will take place. Now see here, you are capturing some videos through your CCTV camera. There is some purpose. You are not just capturing the things for a hobby here it is. You want to track any unauthorized person entered my campus. You want to see in any corner of my campus some any unhealthy activities going on. Fine, somebody is quarreling at some corner, some fight is going. So there is some specific objectives for connecting CCTV camera to the internet here it is. So that means whatever videos the CCTV camera is capturing, somewhere somebody need to process it. Fine, somewhere somebody need to process it. So that way what happened? CCTV camera may be connected to the other end through your gateways, finally through the internet, and to finally the cloud or maybe a backbone infrastructure where the processing of these data will take place, so that some decisions can be taken here, some analysis can be done here it is. So that way what happened, if you see the very simple architecture or the whole setup of your IoT, it looks like this is the place where different sensors or IoTs are connected. Finally they are connected to the internet through some gateways, and finally somewhere at some other point what happened, processing of these data will take place. For example, in the case of health management, so many patients are connected by many sensors and all. Now at one place what happened, the data collected by the sensors need to be processed. so that some decisions can be taken here. In the case of industry also, they connect so many sensors in their industry environment, but finally they want to take some decision here. Otherwise, there's no. So there should be some reason for having a IoT infrastructure in any industry, in any hospital, or any educational institute. Here it is. Anyhow, so this I think in yesterday's presentation they might have covered in detail the architecture as well as the applications of your IoT. Here it is. Okay, this is a very simple overview of IoT because I didn't go in detail because yesterday you had a two good session on applications, layered architecture of IoTs and so on here. Now our main point starts from here. One is the security aspects of IoT, second one is the research aspects of IoT, and the third one is the problem statement. Just for a change, I included one more topic here, demonstration on the different tools. Here it is. Fine, what all different tools are available? Maybe if it is possible, I'll give some demonstration through my laptop. Here it is. Fine. Okay, so the security aspects of IoT. Now here we mainly talk about what exactly the security means in the case of IoT. Here it is. Okay, so all are new to cryptography. Maybe this is the backbone of any security model here, and which we call as a CIA trait here. So CIA, C means confidentiality, I means integrity, and A means your availability. Fine. So this used to be the backbone, foundation of any security system. Fine. When you want to build any security system, you have to take care of a confidentiality, you have to take care of a integrity, you have to take care of availability. Now the confidentiality, as I already told, it is nothing but hiding the information. Fine. Hiding the information from unauthorized access. So this is the very simple meaning of a confidentiality. Integrity meaning is, for example, you send a data like a hello good morning to your friend, and it is expected that he should receive as a hello good morning only. He should not receive it as a bad good morning. Fine. So that means whenever you send some data to other party or to your friend, now there should be some mechanism to figure it out whether the data has been modified or not. So it is not like a very plain communication in the real world. Fine, there are so many challenges are there. Maybe two people in a nice way they are communicating, but there is a third party who is interested to modify your whole communication. There is a third person who is nowhere connected to these two parties and he wanted to make use of your communication. So in such cases, what happened? No, it may so happen that the third person who is sitting in between you and your friend may capture your data, may collect your data, and he will modify and he will send it to the other side. You might have sent hello, good morning, boss. Fine, and the boss will receive the message like a bad good morning. Fine, that should not happen here it is. Now, how you will make sure the data is not modified? How you will make sure that somebody is not modified your data? So this is the other job of your security. That is nothing but your integrity. Integrity means we wanted the data should send as per the original text here it is. There should not be any modification. In case if it is modified, so we need to have a mechanism at the other side to cross check the data has been modified here it is. Fine. So for example, I'll give one more example. So how many of you are comfortable with the Linux operating system? Linux? So your computer, your desktop, we use operating system, no? So we come across Windows, which is a paid operating system. We have to pay the amount. Whereas this other free operating system is available, which we used to call as a Linux. Fine. So when you go for installing a Linux operating system in your computer, so first we need to download it from the internet. Fine. There's a official website for a Linux is available. You have to go to the official website and you have to download. But if you go through the official website of a Linux, so while downloading the operating system for installation on your computer or in your laptop, Linux also provides another information along with the operating system file that they call as a hash code. HASH, hash code. Now this hash code mainly deals with the integrity, because when I download the operating system to my desktop for the installation, it may so happen that sometimes some file may get corrupt. Some file may not get downloaded successfully, and when I go for installing that operating system in my computer, at some point your operating system installation will fail. some point your operating system installation will fail, or the operating system installation may give you the error. This file is missing. I cannot proceed further. Click exit. So some messages will come. So in case of a Linux, what happened? While downloading the operating system from the internet, even we download the hash code that is provided by the Linux official website. Now, what is the purpose of this hash code? After you download the Linux operating system, you can recompute the hash code. Hash code is something like a small number. It is something like a small number which you can recompute after downloading the operating system in your desktop, and you can cross check the hash code given by the official website. Now the official website will say that, so for this file hash code is 123. Okay, now I downloaded the full file. After I downloading the full file, I recompute that in my computer. That is very simple. One simple command, it will generate the hash code. Now after getting the hash code, I'll check whether the downloaded hash code and the computed hash code, they are matching or not. If they are matching, that means my downloading is successful. And in case if there is any mismatch, if the comparison of your calculated hash and the downloaded hash, if they are not matching, it is an indication that your downloading is not successful. Maybe your downloading might have displayed successfully downloaded, but when the hash codes are mismatching, it indirectly indicates that some file, something went wrong here. So in that case, it is not valid to go for a further installation. So then we go for again downloading here. Now this hash code which usually take care of your integrity here. Fine. Whenever I send a message, hello, good morning to my boss, along with that hello, good morning, I'll send the hash of that whole message. Hash may be some number 123. Now at the boss system, what happened? After it receive a message, hello, good morning, it will recompute that hash and it will check the transmitted hash. If they are matching, then the message will be sent to your boss's screen. Here it is. Yes, hello, good morning. And in case if they are not matching, that means something went wrong with your data during the communication here. Fine. So that way integrity will come. Availability, as I told. So when you host any service, it is always expected from the customer point of the service is 24 cross bar, 24 cross 7, it is available. Fine. So even like a banking website, when they want to shut down the whole system for any maintenance purpose, they used to convey all this information to their customer. Today from this time to this time, service may not be available. Fine. So that is the other way we have to take care of it. Otherwise, it is always expected that the service is 24 cross 7 available here. So how to see the service is always available? That is the other very important pillar of your security here. So when we talk about a security system, we indirectly come across the terms like a confidentiality, integrity, and availability. But there are another two: authentication, authorization, and so on. Here it is. Fine. These are the three main pillars of your security, so which is also applicable to your IoT. So when we talk about a security in the IoT, indirectly we are talking about confidentiality in the IoT, indirectly we are talking about integrity in the IoT, indirectly we are talking about availability in the IoT. Here it is. I hope you are getting. So many of you are new to the cryptography. In the cryptography, these are the three pillars. Along with that, another 2-3 are added. Here it is. Okay, CIA, right? Security model designed to guide an organization to end up into a nice security infrastructure, and it consists of a key principles like availability, integrity, and confidentiality. Here it is. Okay, IoT challenges. So here, security is one among them. So whenever you see any particular area, so there are many challenges out there. Fine. So in almost in all areas, security used to be the one challenge. But in the case of IoT, we come across a challenges like a scalability, we come across a challenge like a mobility, heterogeneity, context awareness, and among this, security is also one here. So in the IoT, security itself is not one challenge. There are many challenges out there. There are many challenges out there, and security is one among them. And this presentation focuses this is security here it is. Okay, if you see the scalability, mobility, heterogeneity is like a very important point here. It is because IoT devices, they are not like uniform in nature here. There are different kind of IoT devices are available. They follow the different architecture, they follow the different protocols for the communication. Fine. So nothing is standardized in the case of IoT, which creates another big problem in the case of IoT environment. Like for example, in the smart city application. In the smart city application, maybe you wanted to connect your CCTV with another part of your IoT application. Now they are not so easy to integrate because CCTV may work in one form and your other part of your smart city may work in another form. Integrating them is a very difficult. For example, one of my student who is working on IoT, so his problem statement is a data heterogeneity. Data heterogeneity issues in the case of IoTs, where for example the patient is equipped with a sensors like a temperature sensor. He is also connected with another sensor called a heartbeat sensor. Fine, he is also connected with some other vitals sensors. Now all these sensors, maybe they are from the different manufacturers and they used to provide generate the different formats of a data. The format of the data is also not fixed because there is nothing like any hard code standards we are following in the case of IoT environment. So all these sensors which are a part of that particular patient, they are generating a different formats of a data. Some sensor may generate data of a JSON format. Some sensor may generate a data of a text format, CSV format. There are many data formats are available supported by the different sensors which we come across in the IoTs. Now, if you want to take one decision based on all these formats of a data, first job for me is to integrate all these data of a different formats. Now, that is a problem statement. So, is a problem statement is designing a new framework or designing a new model where the heterogeneous type of a data which comes from the different sensors in a different formats, how to integrate them to take a further decision. Here it is. So that way here heterogeneity, because the devices are totally different in IoT environment and integrating them used to be very difficult. Here it is. So the mobility, because if I wear some watch which can monitor my heart rate and finally which will be connected through the net to my doctor, for example. Fine. Now this watch I cannot fix it in one particular place. Fine. Along with me that watch will also move. Here it is. Fine. So the mobility is a movement. IoT devices, they are not always fixed in nature. Maybe CCTV camera you will fix it in one place, or maybe your internet connected speakers maybe in one place. But not all devices they used to be placed in only one place. They are continuously moving. Now when the moving scenario comes into the picture, then communicating the data of these moving devices to the backbone network used to be another big challenge. Here it is. So similarly, scalability, for example, maybe if you see 5 years back, the number of IoT devices were too less. Now the growth of IoT devices is happening in such a rapid speed. So it is already crossing the limit. Here it is. That means day by day new devices are coming up. Day by day people are thinking how to connect these devices to the internet and so on. So that will be another problem for our IoT environment. Here it is. So context awareness. So context awareness is something connected with the decision making. Here it is. So when some data are collected with respect to the current environment, immediately some decision has to be taken. For example, here already it is very cold and some ACs are turned on. Fine. So immediately we wanted to take the decision whether to reduce the temperature or increase the temperature. Fine, that is with respect to the surrounding environment, some decision has to be taken. So this is the other area where somebody is interested to work in IoT can think of. Here it is. Fine. So if you see like this is the other representation of the same slide, whatever different challenges we saw here. The same thing is presented in this form where you can see security challenges, network challenges, new and complex dependencies, software development challenges. So these are like in general challenges which we come across in the IoT, not specifically to the security. Fine. So this is not specifically to the security. In general, these are all the challenges, issues which we come across in the case of IoT. Now from the security point of view, what are the main challenges? Here it is. Okay, here as you can see here, default credentials and the user neglect. Fine. So default credential in the sense, for example, when you go to a market and purchase any device related to computer network, for example, access point. When you go to a market and purchase access point, at the back side of access point there will be one sticker, and in the sticker they will mention username colon dot dot dot, and they will write password dot dot dot. So that is called the default credentials. So that means to configure that device, you need to connect that device to your laptop and you have to log into that device with that ID and a password. Now that ID and a password, since it is pasted on the backside of a device, which anyone can access it. So this is the problem with IoT devices. IoT, for example, if you purchase any laptop, if you purchase a laptop or a computer from the market, no username, no password is hard coded by your manufacturer. You can customize it. You can fix your admin as a ADIMIN, or you can fix your admin as a ROOT, anything you can customize it. Any password you can fix it, but that is not the case in the case of IoTs. Fine. IoT for the initial configuration need to log in with the default username and a password given by the manufacturer. And manufacturer, to avoid the issues with this login credential, he used to paste that login ID and a password at the backside of the device itself. You can see any IoT device. Most of these IoT devices, either there will be one sticker, or maybe in the catalog or in the manual of that IoT device, they used to provide what is the username and the password. And most of the time, the user who is using that particular device, they normally don't change these passwords. So it is always advised from the manufacturer side, after the first login, please change the password. But we always keep the password as a ADMIN123 or a root123, which is the default password. This used to be the very good entry for the attackers to attack your IoT device. Because once any attacker knows the ID and the password of your IoT device, he can log in and he can start controlling the whole device. So that is what is happening with the CCTV cameras. So CCTV cameras, they are, for example, in my house itself, there are 3 CCTV cameras, which I can access it from anywhere, not just inside my house. I can be in my college, or I can be outside my city. I can be anywhere, but I can access all the 3 CCTV cameras through my mobile phone. I can see what activity is going on here. That means my CCTV camera is connected to the internet. Now that CCTV camera works with my login ID and a password. Fine. So if I don't change the default login ID and a password, anyone can easily hack my CCTV camera. And he can fix the way the CCTV camera should work here it is. And he can fix where the recorded file should be stored. So this is all the attacks are possible because of this first challenge. There is a default credentials and a user neglect. User neglect in the sense, manufacturer will give an instruction after the first login, please change your password. But how many of us will change? Will keep the password as it is. Fine. So this is the main entry for an attacker here. So rushed app releases and insufficient testing. This is from the manufacturer side. So manufacturer, because of the competitions in the market, so every manufacturer, they are in a hurry to release their product. So if somebody designed a new product, so always they used to be in a hurry to release that into the market to attract the customers. Maybe once they release the product, then they will come up with the version 1, version 2, version 3 and so on. First they wanted to showcase in the market that okay, this product has been launched by me. So that will be the brand here it is. Now in this competition world, what happened? Every manufacturer, they will neglect the security aspects in the IoT device. Because usual practice is whenever you want to release any new product in the market, you have to think from all the aspects, whether security side is it okay or not. So that all testing need to be done. Now there is a huge competition in the market to release the product. So they don't check all these things and they easily release the things in the market. That used to be the another problem in the case of IoT security. Here it is. Similarly, if you see growing threat to IoT, malware and ransomware. So malware, this is a cryptographic term. So any idea what is this malware? So these are all common terms in security, that is virus. Virus used to be the common term because we used to come across antivirus like a Norton, Avast, McAfee and so on here is. So that way virus used to be a very common term for us. But in line with this virus, there is another term called a malware. So malware used to be very dangerous in the case of IoT environment here is. So any idea what is this malware? So malware in very simple way, it is nothing but the malicious software. Malicious software means danger software. Virus is very common term for, but it is also called as a malware. It is also called as a malicious software because once a virus enters your system, it will some way it will harmful to your system here it is. Maybe either it will share your confidential files which are present on a desktop to his owner, or maybe it will corrupt the file so that at one point you will see the system is not working properly, system is very slow. Fine, system is not booting properly. Fine. So virus or a malware, they all come under the same umbrella. So malware is a very broad term which also includes this virus. Now this malware attack used to be a very common attack in the case of your IoTs, because IoTs are very easy for attacker to perform an attack, and they easily insert some malicious software or a program into your IoT device. And once that malicious software enters your IoT device, then your IoT device is gone here. So that means even though CCTV camera is present in your house, but it will be controlled by someone who is not a part of your house. Every controlling will be done by him only here. Fine. So that way the malwares, what is this ransomware? Any idea? Ransomware is something like a blackmailing. It is something like a blackmailing kind of attack. What exactly will happen? No? So once attacker gets an entry to your computer, he will target the very important files of your computer. Imagine that there is one file where you store different login IDs and a password. So you are accessing so many accounts and it is very difficult to remember everything. So what usually we used to do, we used to save our login ID, password of a Gmail, Yahoo and many other things somewhere in some file in the protected form. Now the purpose of this ransomware attack is, attacker will launch an attack in your system, and that malicious program, it will search for files which are very important to that particular user, and it will get a control of that particular file. Once it gets a control of that particular file, the genuine user, when he try to open that file, the file will not get open. Now imagine that in that file I stored the login ID of my SBI account, and immediately I wanted to make a transfer of some money to my friend. So I cannot remember each and every login ID and a password. I used to always go through that file to see like what is the login ID password so that I can log into my SBI account. Now what happened? This file has been attacked by the attacker. Now I want to make a transfer. So I'll open that file. The file will not open. The file will not open. File exists, but I'm not able to open that file. Here it is. Now in that case, the attacker will come in the picture and he will start blackmailing the user. See, your file is attacked by me. If you want me to open that file, you have to pay this much money. Here it is. This is called a ransomware attack. I hope you are getting. You cannot imagine the different scenarios of the attack. Here it is. We are in the very plain world. In the sense, we used to always think like if I send something like this, it will go like this only to my other party. Here it is. But that is not the truth. Here it is. The different kind of attack scenarios which are possible in the current real world that we cannot imagine at all. Here it is. Fine. So maybe there is another very interesting attack. There is some specific name is there, which is called a timing attack. In the sense, now for example, when you install any antivirus, many of us are familiar with the Norton antivirus. It is maybe present in your Windows desktop and all. So antivirus, they come with some validity. So 1 year validity or a 2 year validity. So that means if you install that particular antivirus today in your computer, maybe for a 1 year, that antivirus will take care of protecting your computer from unauthorized users. So there is one attack where the attack target is what? The timing of these antiviruses. So validity is 1 year. They will attack and they modify the timing in such a way that the validity will get reduced to 6 months. And after 6 months, you will start getting a message. Your antivirus is going to expire after 2 days. After the 1 day, today it will get expired. So we will get surprised. Oh, my validity was 1 year. And how come I am getting a message after 6 months? Indirectly, there is one attack comes into the picture. Most of the things what you see in your system, like not in the regular pattern they are working. Straightforward, it will click our mind, there is an attacker. Fine, attacker, nowhere they will make an announcement, I attacked your computer, I attacked your mobile system and so on. Here it is. So we have to see the way your devices are behaving and we have to make a guess there is any attack or not. But the very easy way to solve this attack is what? Imagine that if you see your computer is attacked or your some IoT device is attacked, always reboot it. So that's why what happened, manufacturer they always advise to reboot the computers. You have to fix some time and that particular time, so the system will get reboot. So most of the viruses, when you reboot it, no, they automatically get deleted. So now your system is on, attack is performed. And these attacks, they mainly target the memories and they resides in these memories and the memory gets cleared when you restart the system or when you reboot the computers. So rebooting is very important. If you are using a mobile, the good practice is at least once in a day you reboot your mobile. Most of the time, if I switch on the mobile, so I'll not reboot that mobile even for a 10 days. That is not the good practice. The good practice is every day you fix some time to reboot it. Restart the system or restart your mobile. What may happen? Some temporary attacks or the malicious code which are residing in the RAM of your mobile, they automatically get deleted. Here it is. Fine. Anyhow, so then user privacy risk is there, insecure interfaces, because in case of IoT devices, so the ports which are available to access these IoT devices, they are like very insecure because they are not highly protected by the manufacturer side. So that used to be the other problem. Vulnerable remote work environment, then handling large amount of data, because IoTs, they are generating the data like anything. So if you connect a simple one temperature sensor to one patient, for example, that simple one sensor can produce so huge data. So maintaining this data at the server side or at the cloud side used to be the another challenge for the IoT from the security point of view. Unskilled development teams. So most of the time the people those who are responsible, like a security team, those who are responsible to take care of the security of these IoT devices, they are not properly trained with respect to the cyber security. Here it is. So these are some of the security challenges which we come across in the case of IoTs. Here it is. Fine. Now the same picture, the same points, it is represented in two ways. One is IoT challenges from the security device point of view, and another one is the environmental point of view. If you see the environmental point, lack of resources, unclear job roles, because there are many entities which are a part of a security team in any organization. So they need to be very clear cut with their roles. Then only what happened, the security of these IoT devices can be properly taken care of. Most of the time that used to be very confusing type among the people, those are a part of a security team. Here it is. Legacy liability. Legacy in the sense something we are following for so many years, so we wanted to use the same thing even in the future. So that is not accepted here. So as and when the new technology comes, as and when the new things comes into the picture, so we have to see to upgrade those things. I cannot say that okay, 10 years back this was working fine. Why not I can retain the same thing for another 20 years. So that way the things won't work here. Day by day the things are changing and you have to adapt yourself according to these changes. Here it is. Insufficient knowledge, prioritization of the productivity. So here, so that's what I told, the competition in the market. So that creates another kind of a security challenge in the case of IoTs. Here it is. And if you see the left side, lack of secure update system, lack of physical barriers. So physical barrier in the sense, physical protecting the IoT device is also very important. If you are fixing some CCTV camera, then you need to have some nice covering for that, so that from physical damage we can avoid it. Here it is. Otherwise, the first problem that we see in the case of ATM machines, they will first spoil your CCTV camera. They will first break the CCTV cameras because there is no proper physical protection to these CCTV cameras, which are a part of IoT. Here it is. Then insecure and outdated components, insufficient privacy protection, insecure data storage and transfer. This is not exactly at the IoT side, this particularly. This is at the cloud side. As you told, like these sensors, when they collect the data, they don't maintain all this data in their system itself because they are limited in memory. They cannot retain the huge data. So through the net, these data will be transferred to the cloud side or the backbone network. And how you are going to securely maintain these data, that used to be the another challenge from the IoT field. Here it is. What are the IoT's top security threats? Now these are like, this is all from the articles. So this is not mainly from any papers. Mostly these things are available in the article. If you go through any internet and if you study some articles, you will get this history. So where you can see like, so the 100%, it is divided like 41% exploits. So the exploit means the weakness in the system. So computer attackers first target, they see what is the weakness of this system. Fine, if I pay 10 rupees to a security person, he will allow me to enter the campus. That is the exploit. That is the meaning of a weakness. I hope we are getting. You appointed one security person to stop unauthorized access. But somehow I found out that the security person is ready to allow me to enter the campus just by paying a 5 rupees. Now that used to be the weakness of the system. Here it is. Now misusing of such weaknesses, using of such weaknesses by the attacker is nothing but the exploits. So that means if you see, most of the attacks on the IoT device are because of the weaknesses of the system. Here it is. I hope you are getting, because the softwares in the IoT systems, they are not updated. Fine. And patching these softwares also, most of the time they don't happen at all. Then the IoT side, your most of the ports through which these devices are accessed in the internet, they always used to be open. Fine. Default credential, like a default login ID, passwords, owners, they hardly change it. Now, these are like a entry point for attacker to enter into your IoT system. Here it is. And this is around 41%. 41% attacks are happening in the IoTs because of these weaknesses only. Here it is. Then the user practice, the way user is handling the IoT device, because he is very casual. For example, the CCTV camera which is installed by in my house itself, rarely I used to go for updates. Even though the CCTV brand gives a regular message to me, update your CCTV camera, update your CCTV camera, I am least bothered. Here it is. Now this results into 26% of the attacks in the IoT environment. Here it is. 33% is a malware, as I told, malicious softwares. Attacks on the IoT device because of a malware, that is around a 33%. I am giving the full picture of different scenarios of IoT attacks. Here it is. So 41% weakness, 26% laziness of a user, and 33% is because of your malwares. Here it is. Now if you see 41%, one is the network SAN. I will demonstrate one simple tool. Remote code execution, command injection, buffer overflow, others, SQL injection. So there is something called a 0-day. 0-day meaning is administrator don't have a time to patch the weakness of your system. Administrator knows like this IoT, this is a problem. This IoT, this is a weakness. But 0-day means he don't have a time to patch it. So most of the time what happened, the manufacturer who manufacture these IoT devices, as and when they update the system, they will make announcements. See Baba, this vehicle, this is a problem. Get your vehicle to garage, I'll repair it. But owner is least bothered. Owner is don't have a time. Don't have a time means 0-day. He don't have a time at all to go to garage to repair the car. And one day he will met with an accident. Same thing will happen in the IoTs. They release the updates, but the administrator or the owner of that IoT device don't have a time to patch it. So that is nothing but a 0-day problem here. Fine. And if you see the malware side, this is a very serious problem. In the case of a malware side, there is something called a botnet attack. There is something called a backdoor Trojan, ransomware, worms. So botnet, exactly what will happen? Imagine that some IoT devices are connected to the network. Fine. There is one scenario I'll demonstrate in the next slide, where you will see that the attacker will attack on one IoT device in your system, and that IoT device further he will use to attack another IoT device. So that way what happened, it will create a chain of malicious IoT devices. The malicious IoT device, they used to call it a bot, B-O-T. BOT means your bot, which is a malicious IoT device. Initially it was a very healthy, very good IoT device, but the attacker will prepare an environment in such a way that he will target for one IoT device and he will take a control of that IoT device. And that IoT device, now it will work for the attacker, not for that institute. It is indirectly, it is present within the institute, but it is indirectly working for that attacker. Now the attacker will, through that malicious IoT, he will attack another IoT. So that way it will create a chain of bots. Here it is. That is called a botnet attack. Here it is. Fine. So this worm. So worm is another kind of a virus in a simple way, or malware, or a malicious software. So once it enters into another system, once it enters into any system, that virus, once it enters into any computer, what will happen? Automatically that computer, that virus will get replicated to another computers. So there are some virus where the the involvement of the attacker is very important. He will somehow see that the virus get entered into your system and it will start working in that particular system. If you want to target another, attacker will once again send a file to that particular computer and it will install and it will start attacking on that particular computer. But there are some category of viruses are available. Attacker will deploy in one computer and that malicious code itself will move from one computer to another computer. Nowhere the attacker will come in the picture. First time, my investment. First time I will invest something to perform that attack. Done. Once that is done, the code is written in such a way that it gets automatically replicated on every computers. It will automatically get replicated on every IoT devices. That is called a wormhole attack. Fine. So these are all different kinds of attack which we come across in the literature. Wormhole, ransomware, there is a backdoor Trojan. This is nothing but, so this usually used to be kept open by the manufacturer. For example, many times when we get any hardware from some manufacturers and when we want to go for any further configuration, we used to give access to the manufacturer. He used to remotely access your device for any further configuration. That is how the system used to work in the networking side. Fine. So sometime what may happen, like if the system password is forgotten, administrator completely forgotten his login ID and a password and is not able to log into the system, which is very dedicated system, which is very important for my institute. If I stop that system, maybe my whole network in the institute may collapse, which I don't want to do it. Now in that case, what happened when we contact the provider supplier, so he always used to keep in every device a backdoor entry to the device. So backdoor entry which is only known to that manufacturer. Backdoor entry is something like a other way to enter into the device. So that in such critical condition, the backdoor entry can be used by the manufacturer to solve the problem. Now you completely forgotten the password, you don't collect at all what password you set. Now when you call this manufacturer, sir, this is what is my problem, I am not able to log into my computer because I completely forgotten that particular password. But still that manufacturer would able to log in your system and he will change the password also. Now that is called a backdoor entry. Now this backdoor entry many times it will be misused by the attackers. Even attacker can also use that backdoor to enter into your device to implement all these attack. Here it is. So that is actually called a backdoor Trojan. Here it is. So that way what happened? We come across a very big list of attacks which are possible on these IoT devices. Here it is. So here. Okay, so somewhere in the second slide, we saw the different areas of applications of IoT devices. Now, which are the applications which are highly targeted by the attackers? So, if you see here, 51% medical imaging systems. So, this is also part of IoT applications. So, IoT which are a part of a medical imaging systems. So, they are 51% attacks. So, similarly, if you see 33% security cameras, your CCTV cameras. So this is not with respect to any one institute. This is in the entire world I am talking about. If you make a study in the entire world, the percentage of attacks on the different applications of IoT, you will see 33% on the security cameras. Similarly, 26% patient monitoring system. This is nowadays common in hospitals and all they are using. So the percentage of attack is around 26%. Similarly, on the printers, printer is also possible. Your printer is connected and we used to see like some pages are automatically getting printed even though the command was not given by that particular user. Fine. So around 24% of attack in the literature you will see on a printers. 9% they are on the medical device gateways. As I told, your IoT devices are connected to the network backbone through these gateways. Fine. So gateway act like an interface between your particular environment with the rest of the world. Here it is. So there are attacks even on these gateways. 7% attacks on the consumer electronics, because nowadays many electronic items are available which you can remotely control. Your speakers can be controlled, your ACs can be controlled, your refrigerators can be controlled with your smartphone. Fine. There are even attacks of around 7% on these devices. Energy management devices. Energy management devices may be your ACs and so on. Here it is. Even they are also prone to attacks. Here it is. There are around 6%. 5% of attacks on the IP phones. Because IP phone at some level is much better than these IoT devices. They come with a very good processing power, memory and all. That is not the case in the case of IoT here. It is. That way you will see the percentage of attack is very, very less, around 5% here it is. Okay. So anyhow, so up to here we saw like what kind of a different attacks which are possible on the IoTs, and in the real world their percentages here it is. Now the other very important one is a malwares. As I told, malware is nothing but your malicious malware is nothing but your malicious software or a malicious program. And in the IoT field, there is one very popular malware. In 2016, it was released by one attacker, and it attacked almost all CCTV cameras in the USA. Not just any educational institute. At the defense level, the attack was performed on many CCTV cameras in 2016. And its name is a Mirai, M-I-R-A-I. Mirai malware, it is here. And this is just the previous version of these malwares. And what happened, in 2016, this attack was performed on most of the CCTV cameras. And after a few years, this source code was released open by this developer who developed this Mirai malware. No, he released that source code in the GitHub page. So here one GitHub page link is given. So maybe in the next slide you will see a GitHub page link where you can get the source code of this full Mirai malware. So you can download that full source code. Simple instructions are given how to build a setup of this Mirai malware, and you can start executing. Here it is. It's very easy to do it. So that was the one popular malware released for IoT in 2016. That is a Mirai malware. Malware means malicious program. Here it is. Fine. And after the release of this source code, no, we came across a very big list of variants of this Mirai malware. Because a small change in the source code, you will get one more malware. Another small change, another malware. Another small change, another malware. So after the release of this Mirai malware through the GitHub, so many developers, they came across or they designed their own malware by making a simple change in the Mirai source code. Here it is. Fine. So here you can see the percentage of a contribution. Like in the malware side, in the previous slide, we saw around 33% contribution of IoT attack is because of a malware. And among these, almost 46%. 46% attacks are possible through this Mirai malware here. 46%. This gives a contribution of the different malwares which are attacking on this IoT device. And around 46% attacks are only because of the Mirai here. Mirai is the name of one malware. It is the name of one malware which is a malicious program here. So 46% are from the Mirai here. So these are all the different names of the malicious program which we call as a Mirai, the malware here is. Now if you see how this Mirai attack takes place. So Mirai malware, like how exactly it will attack any system here. Procedure is very simple. In the step 1, what happened? First, they will detect any vulnerable devices. They will study your network and they will try to find out the weak devices. Weak devices in the sense the security side, they are not very strong, very easy to attack. So this is the first step which we call as a scanning. The first attacker. So we know like even in the terrorist side also, when they want to perform any attack, first they will take a round of the whole city. They will study where, what is available, where it is a weak point, where I can target for an attack. Here it is. Same thing will happen even in the case of a security side. So first they will study your network and they will list down the weak points in your system. Here it is. That is nothing but detect vulnerable device. Brute force user credentials. Now Mirai, its main target is your IoT device, but that is through the default credentials. Default credentials in the sense default username and the password. If you don't change it, that is the easy way for attacker to attack. And the Mirai target was that one only. It used to search for the IoT devices where the default IDs and the passwords has not been changed. And through that default ID and the password, this Mirai will enter your IoT device. Here it is. So here brute force. Brute force means it will check all combinations of your ID and the passwords here. For example, I'll open one website. So which is DEF. Okay, let me little bit zoom this. I hope now it may be very clear. Okay, let me go for 150. Okay, now this is one website which anyone can access it. It is a defpass.com, defpass.com. This website, whichever model of any device, if you pass it as input to this website, it will show the default ID and the password of that particular device. So let me check. Just I don't know which specific model it is, but I'll type here link. I'll just type link. Okay. So there is a big list. Let me zoom it a little bit more. Okay. Now what happened? It displayed me lot of informations here from the different. I just typed link. Link means according to me may not be a D link, may not be a TP link. These are main manufacturers of your computer devices. Fine. I just typed link. Now this link query displayed so many informations from the different manufacturers. Let me go to, for example, this is a D link. Here you can see vendor is a D-Link, device is DI604. You can type in the Google DI604. You will see this is something like one router. Fine. And you can see here it's a default password is admin. So here it's a default password. It is given. Login ID is admin. There is no password at all for this device. If you purchase this brand device from the market, which is manufactured by D-Link, a router very important equipment in your network. If the router is not working, the whole network will collapse. Fine. So router which is brand by the D-Link, if you see its password is none. Fine. So maybe if I'm not familiar with this device, maybe I'm not knowing like what is the password and ID of it. But in this website, you will get almost all devices login ID and a password. Similarly, if I go down, so here if you see, I'll open another. So see here, all are D-Link. Let me show you for the TP link. So TP link, for example, here. You can see here, vendor is TP link, model number is this, and it is access point. It is access point. So its default login ID is admin, default password is admin. Now see here, these default credentials are not secret information. So they are by default available at the backside of your device, or maybe they are available in the manual page of those devices. You can easily search it in the Google. Now the meaning of that brute force attack, it was written, the second step is brute force. What the malicious attacker will do, once he figure out this is a weak IoT device, he will try to log into that IoT devices with a lot of combinations of a user ID and a password. He will try admin, not working, root admin, no, admin 123, no. That way what happened, he used to have a big list, and this is all not done by manually. He will write a script for that. He will write a program. In a 1 minute, it will figure out what is a valid login ID and password, and he will get access to that IoT device. And once you get the IoT device, then it is your control here. You can do anything here. So the Mirai malware, very popular malware in the case of IoT field. Its very simple logic is target the default credentials. Target the, if you are not changed the default password of your device, then it is a very easy point for attacker to attack your device here. So this is a website where you will see the default login ID and the password of many popular networking devices here. It is many popular networking devices. We just typed link, L-I-N-K, not specifically to any brand. Just we typed a link, and you can see there is a big list of devices where you can see their default ID and the password here. And through such data, the attacker will perform an attack here. It is. So that what happened here. So the first step is he will detect the vulnerable device, brute force user credential. Brute forcing means trying everything. First he will type admin 123, root 123, root admin 123. He will make all these attempts, and one attempt definitely will click. Here it is. Okay, then download and executing the malware. Now what the attacker will do, once he get the entry to your IoT device, then he will download his malicious program into your IoT device. He will install the malicious program. He will download the malicious program into your IoT device. And once the malicious program is downloaded, by sitting in a remote place, through that malicious program, he will control your IoT device here. He will control your IoT device. So controlling means what happened through that particular IoT device, he will perform attack on another IoT device. Because attacker, when they perform any attack, their one main goal is they don't want to disclose their identity. So by sitting backside of another device, they will perform the attack. So if somebody somebody track the route, he will reach up to that IoT device. After that, they don't get a path from where this attack was performed. So that way what happened, attacker normally they don't attack any system directly. First they will take a control of some system, like first I'll get the confidence of that security person who is standing at the gate here. Then through him I'll perform the attack. But I'll not disclose any credential to that security person. If somebody track and reach up to the security person, if you ask who had given that 1,000 rupees to do all these activities, no sir, somebody came and I don't know his name, I don't know who was from which place and all. Now that used to be the main aim of the attacker. They attack any system, but at the same time they keep their IDs confidential here. So that way here Mirai, what it does, it will select one weak IoT device in your system, it will perform attack on that, and through that IoT device they will perform attack on other devices here. Tracking will be very difficult in that case here. So this is how your Mirai attack used to work. Maybe the further detail you will get it here, like as I told the GitHub page. So maybe I think it is not okay. This is a GitHub page. So maybe if these PPTs are shared, so you can open this GitHub page. So this is a GitHub page of your Mirai source code. Mirai is a very famous malware in your IoT field, and its complete source code is available here. This is a complete source code of your Mirai malware. You can go through the simple readme file here where the instructions are given how to build a setup so that you can experiment with this Mirai malware. So if anyone is interested, in a single laptop also you can do it. In a single laptop, create some virtual machines. Create some 2-3 virtual machines and configure each of this virtual machine as per the requirement of a Mirai, and you can experiment this Mirai malware kits. The full source code is available in this GitHub page here. It is. Okay, so this may be the further detailed picture of your Mirai malware. As you can see here, this is your malicious IoT now. So attacker performed attack on this IoT. Now what this IoT, which is a part of your system, which is already hacked by your attacker, now it will check any other IoT devices which are easy to attack. Now see here, it is not attacker is doing. Attacker took a control of one student or one person in that institute, and he will train that particular person. See Baba, you have to do this for me. And that person will do all the job. Finding it out, is there any IoT device which are easy to attack, and that information he will convey to the report server. Now when you go through the GitHub page, you will see all these entities. Report server is nothing but there is one more server which is a part of a Mirai malware, and this malicious your IoT device, it will report to this report server saying that okay, there is a one more person who is very easy to attack. Fine, the report will go to this. Then the CNC server. CNC server is a very main entity where the attacker used to sit here. Attacker, he used to sit here, which may be anywhere in the world, not exactly in one particular place. He can sit in any place here it is. And from this report server, he will get the status. Is there any network? Is there any device in your college is easy to attack? That report he will get it from this report server. Once he get that, he will issue a command to something called a loader. There is another called a loader server. The loader server job is downloading the malicious program into that IoT device. So see here how systematically the things are managed. So in this environment, finding it out who is controlling this CNC server is very difficult. So see here, in this environment, there is no one person. There is nothing like only one attacker is present. There are so many entities are present here. Fine. This person job is convey where he can perform attack. This person job is downloading that malicious program into that IoT device so that that IoT device will come into the control of attacker. So that way here, infect command will be given to this loader. Then the loader will download the malicious program into your good IoT device, and automatically what happened, this good IoT device will turn into a bot. Bot means your malicious IoT now. Fine, it is a dangerous IoT device in your system. Here it is, because this is already compromised. This is already, control has been taken care by some third party. Here it is. Fine, so that way it is shown by a red color. See here. So many, now see here, once the attacker gets a control of these IoT devices, okay, what he will do? Now that is my next question. Okay, he got the control of this CCTV, this CCTV, this CCTV. Further, what he will do? Is it an attack? No. Attack is not exactly this. Attacker is targeting some server. Now your KLE college is hosting one server where many students from outsider they can do the admission, for example. Now what these CCTV cameras the attacker will do? He will instruct these CCTV cameras attack this server, and they will start sending so many requests to the server, and server at one point will crash. And once the server will crash, what will happen? Outsiders they will not get access to your service. Here it is, and they will start blaming, and they may migrate to some other service. Here it is. I hope you are getting. So attack means this. Here it is. So that is what is shown. Finally, with all these IoT devices, he will target some server. Server where services are hosted. Servers where, for example, IRCT website for railway booking. Fine. So they are maintaining some servers to provide these services of booking. Fine. If somebody target that IRCT server, then the server may not allow anyone to go for a booking. Then what the customer will do? They will shout on that IRCT server saying that service is very poor and so on. What exactly happened? These kind of attack might have taken place on the IRCT server here. So that's why what happened? The IRCT server is not providing any service here. So once they get a control of these CCTV cameras, once they get a control of these IoT devices, they will instruct this IoT device, see Baba, this is your target, attack it. Then they will start sending a request. Here it is. That I will demonstrate here, how to perform these attacks. Here it is. Anyhow, the point here it is, Mirai is one very popular malware in the field of IoT. Here it is. Fine. Without Mirai means, so it is incomplete here. So that's why I took the Mirai malware here. Again here, so up to here we saw overview of IoT, where what exactly is IoT, what is IoT security, what are the issues in the IoTs. Then we saw the simple application of IoT. If you remember, the third slide was IoT challenges we saw. Fine. So IoT architecture. Then in the case of the second point, security aspects of IoT, we saw the different kinds of attack which are possible in the IoT, the percentage of these different attacks in the real world, which attack is very severe in the case of a real world. So that is what we saw in the case of the second one. The third one is a tools demonstration. There are many tools are available. I'll show these tools one by one. Ping. How many? Okay, so okay. How many of you are familiar with this ping? P-I-N-G. Ping is one command. Ping is a command which works on Linux as well as a Windows. So here many are new to the computer network. So ping is a very common command which usually everyone knows it. So this ping command we run it to check the availability of some computer. In a network, if you want to know whether this computer is present or not, whether this computer is running or not, so that we used to check it with the help of the ping command, very basic command. Very basic command. For example, how this ping command can be used by the attacker. If I know CCTV camera is this, which is connected to the network and its IP address is this. So I'll first run the ping command to check whether I can reach that CCTV camera or not. First I need to be reachable, no? So then only I will perform attack. So once I detect any device is malicious, once I detect, okay, here I can perform attack. So maybe the attacker can make use of this ping command to check whether he can reach that particular device or not. And this ping command you can easily run in your, for example, in case of, for example, this is my terminal. Let me zoom this. I hope you can see. Ping. See here. This is, I am in Linux now. So you can even run it in Windows also. Ping. www.google.com. Ping www.google.com. So see here. This is all the responses I am getting. So when I start getting the response, it means I can reach www.google.com. So Google, which we use to search different topics and all. Now Google is also maintaining its own server. Now I can check whether I can reach google.com or not just by using the ping. Here it is. Fine. So similarly, even I can check your college if any URL is there. I can type ping the name of your college URL and I'll start getting these replies, which means that I can reach this particular device. It's a very simple tool. So the other tool you can see here, Wireshark. This is the other tool. How many of you are familiar with this Wireshark? So Wireshark is another popular tool in the network. Wireshark. This is not just used by any attacker, this can also be used by any network administrator. Whenever network administrator end up into any issues in the network is not working, but everything looks fine, they are all connected, power is on, systems are on, everything is on, but still other people are not able to access your internet or your service, then the network administrator will use this Wireshark tool. Wireshark tool is a packet capturing tool. Packet means the data what the two computers exchange, we call it as a packet. Packet in the sense if you are sending hello good morning to your other friend. So this hello good morning will go like a packet. Fine. Now these packets you can capture it and you can analyze it. Analyze means you can study the packet, what exactly is happening in the network. So that you can do it with the help of this Wireshark tool. Very important tool. And this tool works on Windows as well as Linux. OpenSSL. OpenSSL is actually a cryptographic library. OpenSSL is a cryptographic library which provides many cryptographic algorithm which we can use it in our application development. For example, you might have heard HTTP and other one is a HTTPS. So online, if you are accessing your Gmail, for example, or if you are accessing any banking websites, so you will see HTTPS. For example, here. Okay. So like gmail.com for example. So we just type gmail.com in our browser here, but it actually starts with a HTTPS. HTTPS is hypertext transfer protocol with a security. So whenever you are developing any application for your communication, and if you want that application should be secured in the sense confidentiality, integrity, availability, everything has to be taken care. So there is one library available which provides all these facilities which you can easily add it into your application. And the name of that library is OpenSSL. The name of that library is this OpenSSL, which is here. Fine, a software library for application that provides secure communication over the computer network. Other than Kali Linux. Kali Linux, Kali. Any idea? So Kali Linux is an operating system. As somebody pointed out, it is an operating system, but it provides a security framework. It provides a lot of security tools. If any one of you want to experiment security related things, the best OS is the Kali Linux. Because Kali Linux by default supports most of the security tools which we normally come across in the literature, any you name any tool. So these tools are by default available in the Kali Linux, which you can easily install it. Similar to your Linux operating system, you can install this Kali Linux. Once the installation is done, you will see many tools by default they are available. HPing3, HPing3, this is the other tool. So this tool comes in the case of your Kali Linux. And this tool is mainly used by the attacker for performing the attacks. I'll show you how to use this particular tool. HPing3. So let me go to Linux, Kali Linux. So my Kali Linux is installed here. So VM. So my Kali Linux is installed in the virtual machine. So let me start this. Okay. So it is installed in virtual machine. So let me log in. So as I told, the first step of any attacker to perform any attack, he will scan the network. He will scan the system to figure it out. Is there any opening for me to enter into that particular computer? Fine. So that is usually done by a very simple tool available, which is called a nmap. In Linux, there is a very simple tool is available, nmap. By running the nmap, you will get the result, which are the ports in that computer, they are open for entry. Because I need some gate, no, to enter your campus. First I need to see which gate is very easy for me to give an entry. Once I get the detail of that particular gate, then I'll study how to perform entry through that gate. Maybe some security person is always present over there. Then I'll target one security person. Then I'll negotiate the things, and he will give access to your campus through that gate. Here it is. Okay, so here there is one tool called a nmap. If I run the nmap command, it will show the open ports. Once I get that entry, the next job is perform the attack. Okay, so this is the Kali Linux actually. So if anyone is interested in security, so I think the best choice is the Kali Linux. You can easily install it. There are many videos are available, many documents are available where it is explained how to install this Kali Linux. Maybe for a UG students, maybe for a PG student, I think you can explore this. Okay, so this is the terminal. So now in my computer, there are two computers are running. In my one single laptop, two computers are running. One computer is my laptop itself, and within that I am running another computer with the help of a virtual machine. There is a VM installed, and that VM runs your Kali Linux. Now if I run if config, how many of you are familiar with this if config? If config. What is this if config command? If config in the sense what IP address is assigned to your computer, because every computer in the network they are connected by IP address. Every CCTV camera, every IoT devices, if they are a part of a network, that means IP address definitely has to be present, and the IP address I can check it. In my case it is equal to this is the IP address of my computer. Now let me see which ports are open in my computer. Fine, with the help of this command, here it is. Okay, so here we just zoom it. I hope you can see this. It is in blue color, slightly one more. Okay, so see here, I'll run the command nmap and my IP address is this. Once I run it, okay, now we get some result here. Now this nmap is to figure out which ports through which we enter the computer. Outsider can enter a computer, your computer, only through these ports. Ports are like a gates in every computer here. Now we executed a command, very simple command, nmap and the IP address of my laptop I had given, and it displayed this result, which says that FTP open, SSH open, here open. Then there are some more services which shows open, open, open. In the sense, these are all the gates to my computer, they are currently open. FTP here, FTP is actually a file transfer protocol. File transfer protocol which actually runs on a port number 21, which is a TCP. Now this TCP is actually a computer network term, transmission control protocol. Fine, it says that FTP port in my computer, it is open. So once this is obtained by the attacker, what the attacker will do, he will start attacking this particular port where my FTP application is running. Now this SSH for the remote login. If somebody wants to remotely log into my computer, he uses this SSH. Even that is also currently open here in my computer. Usually we have to keep all these ports closed. We have to keep all these ports closed, because if we keep these ports open, then anyone can make an attempt with some ID and a password to enter your computer. And once somebody gets an entry to your computer, then he can do anything by sitting inside your computer here. Now this is the very simple command nmap where attacker will check in a computer which ports are open. This is the first step. Once this is done, once it is identified this gate is open for me to perform attack, then he will use this hping3. He will use this hping3 command to perform the attack. So let me quickly go through it. So we saw this hping3. Okay, even I wanted to show this one Diffie-Hellman key exchange. So because many of you are new to the your cryptography, maybe I'll skip this because Diffie-Hellman is a very popular algorithm in the case of a cryptography. Diffie-Hellman key exchange. Because when two people want to hide their information through encoding and decoding, first they need to share some key. So key is something which the sender will use for encoding, encryption, and the same key at the other side the receiver will use for a decoding, that is for the decryption. Like a good word, you will send it like a 123 hash. That is after the encoding. Now this encoding has to be done by the key. At the receiver side, 1234 hash, once it is received, he will perform a decoding operation using the same key to get back the original data. Fine. And during the transmission, the data will be transmitted like a 1234 hash. Even somebody can capture it through the Wireshark tool, still he may not able to read what exactly that the data is because it is encrypted here. Now to perform this encryption, what happened? The sender and the receiver, they need to share some keys. They need to share some keys. Now the key sharing, if they are very close to each other, okay, manually they can go and exchange the keys. But if they are sitting, one is in India and another in the USA, and they want to exchange the data in the secured form, then key sharing manual way is not possible. So one algorithm, very popular algorithm will come, which is called a Diffie-Hellman. Diffie-Hellman key exchange algorithm, where sender and the receiver in the cryptographic way, they exchange the key and the same keys are going to be used by the sender for encryption and the receiver for the decryption. Here it is. Now how exactly this key sharing takes place, that if you go through the Diffie-Hellman, you will get the idea. But in the Diffie-Hellman, there is one attack is possible which is called a man in the middle attack. Man in the middle attack in the sense, now two people they want to communicate, there is one third person which is not known to the sender also, receiver also. Receiver or a sender, they don't know there is a third person is involved in our communication. What the third person will do, when Suresh wants to send the data to a Khan, the third person will intercept this Suresh data, he will read it and he may further send it to the Khan heads. What the Khan will think, okay, this data is directly coming from the Suresh, but in between the third person is reading it. In between the third person who is sitting in between this Suresh and the Khan, he is capturing the data, he is reading it. If it is possible, he can modify and he can send it to the other side. This is actually called man in the middle attack. Between the two parties, there is a third person who is sitting in between and is capturing, he is reading, he can modify and he can further send it. Here it is. Now, here it can be easily demonstrate how this man in the middle attack is possible in the Diffie-Hellman. So here this is the very simple picture of that man in the middle attack, which you can easily run it through a OpenSSL. I showed in the tool list OpenSSL, which is actually a cryptographic library. Now with the help of this OpenSSL tool, we can easily demonstrate anyone, see Baba, what is this man in the middle attack and how exactly it works. So here step-by-step instructions are given. Step-by-step commands are given to run this man in the middle attack. Here it is. Fine, which exactly matches with this particular diagram, which is very much suitable in the case of a Diffie-Hellman key exchange. Now this is like a very simple picture of your man in the middle attack, which is also possible in the case of IoT field. Okay, now here, as I told, some commands, one is a nmap. Nmap, enter the IP address of the target. This will display which are the ports are open. Similarly, if you want, once we figured out one particular port is open, if you want to perform attack, these are some of the very simple command you need to run it. If you run these simple commands, you can easily perform attack on any machine here, which I can do it even from my laptop also. If I run these commands, you will see now the target IP. For example, if your target IP is your college some server, fine, you give me the IP address of your college server, I'll perform this attack. I'll run this simple command. After some time, you will see that your server will get hang. Here it is. I hope you are getting. Now, it may so happen that in the server there will be a log file. Most of these devices, they maintain a log file. log file to check like what happened. Like in the aeroplane and all, there is something called a black box. Fine, black box to study what exactly happened before this accident and so on. Similarly, these systems will also maintain a log file. Through the log file, you can check who did this particular attack and they can figure out it was from my machine. Now I want to hide myself. I want to hide myself. There is a command here. So see here. So here, this command. In this command, what happened? I can enter the fake IP address. I can use your principal IP address here and I can perform this attack. In the log file, what will happen? Your some authority's IP address will be recorded. And when somebody track who performed this attack, they will see the IP address of so and so person. So in that case, what happened? It is very difficult to find out the attack was performed by my computer here. I hope you are getting. Similar kind of a thing, even you can do it on the IoTs. Same command I need to run it. From my laptop, if some CCTV is there, I can check what is the IP address of that CCTV and I'll run any one of these commands. Your CCTV will stop functioning. Here it is. I hope you are getting. Here it is. Anyhow, so this actually we wanted to demonstrate by running the command, but I think it is a shortage of time. It is very difficult. Fine. Okay, the fourth point, research aspects of your IoTs. So this is the other way of presenting your IoT architecture. Fine, where you can see these are your sensors. Through the gateways, they are connected to the internet. Next, from the internet, it is connected to the high-end servers, where further analysis of these data will take place. Here it is. Fine. So that way you will see devices means your different sensors. Fog computing and edge computing. Any idea what is this fog computing and edge computing? Now, I think the main drawback here is almost all are new to the communication. Here it is. All are new to computer network. So this fog computing, edge computing, they are like a very hi-fi terms in the case of communication and very good area of research also. Very good area of research. So here fog computing, so almost all services we deploy at the gate level. In the IoTs, what exactly will happen? Gateway just act like collect and send it to the other side. Now the researchers are thinking, why not some kind of a processing we can do it at the gate level itself? Why to shift everything at the cloud? Because if I shift everything at the cloud, the delay will be more. The time for a response will take a more time is required. So that I can minimize it if I process at locally. Fine. So if I can have a printing machine within the campus, I can take a very quick printouts instead of sending for a printout to some city. Here it is. So same thing, shifting the processing, the required processing at the gate level, that is actually called a fog computing. And the edge computing is shifting this process at the user side here. Now this is your device. Now here, this is your device here. This is your device. Shifting at the device side is your fog. Shifting at the user side. Users are sitting here. Your doctor is here. He is not here. Doctor is somewhere here. Who reads the patient's data. So shifting all the processing at this side is nothing but your edge computing edge. So that way, if somebody is looking for some area of research in the case of IoTs, he will also come across fog computing in IoT, edge computing in IoT. The whole point here is shifting the processing at the edge side or at the user side or at the device side. Here it is. Okay, I think this yesterday's presentation they might have covered it. Different layers and the different protocols. According to the, you can see there are 4 layers and these boxes they represent the different protocols that we come across in each of these layers. Fine, these are the different protocols. Here it is. Okay, now what kind of attacks are possible in each of these layers? So here you will see a very big list of attacks which we come across at the perception layer. There's a top bottom layer in the IoT, then the network layer and finally the application layer. Now here if you see there is one attack called a Cinderella attack. There is an attack called a Cinderella attack. Now this Cinderella attack is actually like I told in one place like changing the time. Changing the time of your antivirus. Fine. So antivirus is valid for 1 year. Now this attack will attack our system and it will change the your time of your system so that the antivirus will get expire earlier. So this is a one kind of attack which is a Cinderella attack. So that way if you see each of these layers they provide a different kinds of attack. different kind of attacks are possible in each of these layers, which are a part of your IoT. Here it is. So this is once again the same thing. This is from another document where you can see attacks can be from the internal, attack can also be external. Like somebody being within the campus can perform an attack, that is the internal attack. Somebody from outside it will attack. But outside attacks are easy to detect or easy to stop. But inside attacks are very difficult. Here it is. Inside attack in the sense your friend only attacking is your system. Your friend who is sitting next to you, so he is only misusing your computer. That is your internal attack. Internal attacks are very difficult to identify here. Anyhow, so in each of these layers, you will see so many different types of attack. There's a very big list of attacks which are possible in the case of IoT environment. Here it is. So here physical layer, network layer. So in each of this layer, you will see different very big list here. There's a very big list of attacks which are possible in IoTs. The last one is what are the solutions available for each of these attacks. Now this may be from the research point of view. Many of you are interested to work in IoT or in security of IoTs. Which are the different areas which you can target here is. Now to deal with these security challenges in the case of IoT, we come across the solutions at the machine learning side. How many of you are working in machine learning? Okay, one. How many of you are working on edge computing, cloud computing? How many are blockchain? Okay, anyhow. So see here, these are the different ways the security challenges of IoTs can be mitigated. Machine learning, mainly we work on the data sets. Fine, we collect some data set, we write a code for that, we run the different models to study what exactly might have happened in the network so that some precautionary steps can be taken to mitigate it. I hope you are getting. Machine learning, we come across many machine learning models to study the data set to identify the attacks. Edge computing, as I told, it is at the device side. Cloud computing, it is at the user side. When the data are huge data which we are getting from the different IoT devices, when they are dumped into the cloud, how exactly the processing need to be done, what kind of a securities we have to provide to these data which are stored somewhere in the cloud. So that is all the challenging problem here. Blockchain is a very like a recent area. So blockchain is something called a distributed ledger. Fine. So like in olden days, we used to maintain a registers. So when somebody entered the college, he put a signature on the registers. Now these registers are very easy to attack because anyone can remove the page, anyone can overwrite it. You entered at 10 o'clock and next day you can come and overwrite it as a 8 o'clock. Anything is possible. Now how these problems can be solved? The solution is a blockchain. The blockchain is the best solution to address these problems. Whenever something we are maintaining in the ledger form, you can easily solve this problem with the help of a blockchain. Now, if you go through the literature for IoT security, even you will come across many solutions by using the blockchain concepts. Here it is. Fine. If you see the blockchain side, the security side, they are very good. And architecture, they always follows the distributed and decentralized. Latency is very high, but the problem is energy consumption in the blockchain is very high here. Energy consumption because these IoT devices, most of the time, they are battery operated. They are battery operated. Best utilization of the energy of a IoT device or a battery used to be the key point in the case of IoT research. Here it is. Now, if you are using a blockchain to mitigate these IoT challenges, then what may happen here it is the energy may go quickly to zero. Here it is. So this is a problem we have to separately address it. Here it is. So that way what happened, you can think of machine learning in the IoT security, you can think of edge computing, fog computing, blockchain. These are all the different areas available if you want to do any kind of a research in the IoT security. Here it is. Now these are the 10 points. There is something called the OWASP. So Open Web Application Security Project. This is one kind of a forum where they used to list all the security issues of different services. And if you go through this OWASP in 2018, they highlighted 10 different challenges in the case of IoT security. And this is a list. Weak guessable password, insecure network, lack of physical hardening. So these are the 10 points which are highlighted by the OWASP with respect to IoT service. And the last one is, what can be the future problem statement? If somebody is interested to work on IoT security, around 7 problems are highlighted, which you can take up like your major project also. If somebody is interested in major project, any one of this topic you can select like a major project yours. If somebody is interested in the research line, yeah, any one of these you can take it like a research problem statement. Here it is. So this is all related to your IoT security. Here it is. Fine, it's a very big area, not like a very small area, very big area. There's a very good scope for the researchers and the student to pursue their higher studies. Here it is. Fine. Okay. Yeah. So that's the end of my presentation. If there are any questions, yeah, it is open. At least something you understood or not. Okay, at least one, two question.
We have authenticated all the clouds, but you are saying that it is a less secure.
Which one?
This you
Yeah, cloud less secure in the sense clouds are also there are many challenges are there. Cloud side in the sense you are collecting so many huge data from these different IoT devices and you are dumping at one place. So what kind of a securities you are going to provide, how you are going to take care of authentication, authorization, still they are the challenging problem. It's not like a not completely addressed. There are some solutions are available with many feature points here it is. Fine. So that way if you see at the gate level, so there are very dedicated gateways are available for this IoT environment. But still you will come across many issues here it is. At the cloud level, at the device level, nowadays the devices are very much sophisticated, but still there are some issues are there here it is. Many protocols are there, application layer, network layer. So one of the other drawbacks is still it is there from the security point of view. Because security is not like a very main goal of these developers. Their job is okay, end up into some service for this IoT so that they can attract the customers. When we
saying that all the data is in cloud means it is
no no no, there also from the IoT point of view there are many issues are there here. Yes. Okay. Any other? Okay. So if there are no questions, then I'll stop my presentation here only. If any further communication is required, you can write to me brc@nitk.edu.in. Fine. So if you are interested to pursue your research in NITK, yes, it is possible here. Yes. Fine. If anyone is interested through a QIP or through institute scholarship and all, that option is available in NITK. Yes. And for MTech and for UG student, if you are interested for any internship work, 1 month, 2 month, if you want to spend in NITK, that also we encourage here. Yes. Fine, just write to me brc@nitk.edu.in. Enough here. Fine, and any project related issues also, I am open for a discussion here. Fine, anyhow, I'll stop here only.
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insight you have provided.
Now I would like to request Dr. Bahubali Akivate to present the movement to our resource person. Thank you, sir. Now I request everyone to follow for a 10 minutes tea break.
experience for your users. Maybe you want your application to generate in-app purchase options during a gaming session, rapidly validate street address updates, or make image thumbnails available instantly after a user uploads photos. To make this magic happen, your application needs backend code that runs in response to events like image uploads, in-app activity, website clicks, or sensor outputs. But managing the infrastructure to host and execute backend code requires you to size, provision, and scale a bunch of servers, manage operating system updates, apply security patches, and then monitor all this infrastructure for performance and availability.
I request every participant to gather for next session. Welcome back. The day 2 second session to be held on the topic Associated IoT Technologies, Cloud, Fog, Edge Computing by Dr. Sridhar Domanar from Accenture, Bangalore. Now, I would request Sneha Shirati to introduce our resource person to the gathering.
Good morning, everyone. It's my privilege to introduce our today's resource person, Dr. Sridhar G. Domnar. Sir is working as a cloud architect Bengaluru. Sir completed his BTech and MTech from VTU and further received his PhD from NITK Surathkal on cloud computing. His core interests include cloud computing, microservices, and machine learning. He has published many research articles in peer-reviewed journals, transactions, and conference proceedings in reputed platforms such as IEEE, Elsewhere, and Springer. Sir has given many technical talks at various institutes and venues. During his PhD, he worked in Clouds Lab from University of Melbourne, Australia. He has vast experience in working with industry research labs and academia. He started his industry career with IBM as a research intern and then cloud architect. He worked on an autonomous cars project titled Cloud Assisted Real-Time Methods for Autonomy as a joint collaboration project with Jaguar and Land Rover R&D. Dr. Sridhar has also worked on areas pertaining to automated cloud build and orchestration. Apart from work, he is passionate about traveling, cooking, and cycling, among other varied interests. Thank you.
Thank you, Sneha. Now I would request Dr. S.G. Golagi to welcome Dr. Sridhar Domnar. Thank you, sir.
The Internet of Things has the potential to change the world, just as the Internet did. Today, to enlighten us about associated IoT technologies like cloud, fog, edge computing, we would like to invite Dr. Sridhar Domanar from Accenture, Bangalore.
Good afternoon. Can you please come front? No, we'll have a discussion, so that's why I'm asking. Can you please come front? I will not bore you people for sure. If you answer, then it won't be a boring session. If you don't answer, then definitely it will be a boring session. Shall we start? Okay. Thanks for the warm welcome, and it's my privilege to be a part of this workshop. And thanks to Principal Sir, HOD, and all the management staff from KLE Chikodi. Yeah. In the next 1.5 hours, so we will be speaking about associated IoT technologies. The title says the cloud, edge, and for computing. So since yesterday, the FTP has started, and we have almost learned with what is IoT and different case studies, and what are the different applications using IoT, and also how the IoT is helpful in today's era in different environments and different fields. It may be medical field, it may be a transportation, it may be bioinformatics, whatever. So IoT is being used in diversified fields, and in this session, so mainly we focus on any project of IoT which comprises of edge and fog computing. So when I say IoT, there is a involvement of edge. Okay, so IoT devices means Internet of Things. So they will gather the data and much more. And to process those data, there has to be something, right? There has to be some computer. There has to be some algorithm to be run. So those can be executed, or those can be executed, and this can be performed in different locations. Okay, so one might be in the same location, or in the edge location, or in the cloud locations. So there is a difference between when the process or when particular uh, any particular action is executed nearby location or at the cloud. Okay, so mainly IoT devices have the capability to absorb the data from different angles, from different persistence, from different angles. Yeah, I mean, they may be having different sensor, they may be acquiring different data. Only they acquire data and they will send it to nearby location. But after getting the data, what is the importance? So how the edge capabilities and other cloud capabilities helpful in the IoT data gathering and helpful in executing the given task. So that is the major agenda of the today's talk. So we'll be going through what is industry evolution, cloud and services, and architecture, mainly because when the IoT is there, when there is a edge computing, so there is a lot of changes in the architecture. Earlier, we have the pointer. Yeah, we have the architecture of monolithic. So everything is in the same system, like database, front end, back end. So if one goes, then everything goes. So now slowly, now we are using the microservice oriented architecture. Okay. So what do you mean by microservice oriented architecture? So how many of you use Amazon app? Everybody uses, right? Amazon app. So when you order food from Swiggy, Zomato, or when you go, I mean, in the metros with Ola and Uber. So all the dynamic apps, whenever we say, so they use all these microservice oriented architecture. So we'll come to that point. What do you mean by microservice and how it is helpful in IoT and edge capabilities? Then IoT principles and what is edge architecture, IoT platforms on cloud. So here we'll go with one case study in which how the cloud is enabling the IoT platform. It means that what are the different capabilities or different platforms and services which will be helpful for executing the IoT capabilities. How the cloud is enabling the IoT capabilities so that all the IoT applications and all the IoT platforms getting together and execute on the cloud and the edge platforms. So how the cloud is enabling the IoT. So those we will study in the IoT platforms for cloud, on the cloud. Then we'll have one case study. So all these technologies, how it is helpful to take up or to execute any one use case. Okay, and the use case will be like autonomous driving. Okay, how the autonomous car, one car can move from point A to point B without any human intervention. with the enablement of IoT and edge capabilities and backed up by cloud computing. Then we'll have some discussions on the research trends and whatever the questions we have. Okay, are you clear with the agenda? So what we'll be studying in the, or what we'll be discussing in the next 1 hour. Okay, so I think most of you know, and some of you may not be knowing, that we are currently in the industry revolution 4.0. So what do you mean by industry revolution 4.0? As you can see here, industry 1.0 that started in 1784, I mean in and around, then 2.0 in 1870s, and in 3.0 after our independence. Then currently we are in 4.0. So initially this 1.0 mainly on the mechanical instruments, so that is with a pure industry, okay, not the digital industry, only the complete the skill labors are required. So complete mechanical industry was started in the 1.0. Then in 2.0 slowly the mass productions like cars and all. Then in the 3.0 automation, slowly the computer has been evolved, the internet, etc. Then in today's world it's totally different. We have IoT, the complete automation. There is a new buzzword in the current era called generative AI, artificial intelligence. Now comes the generative AI. Then we have, there are many things now. So this all comes under the 4.0, robotics, cloud computing, and now the above the cloud now it is serverless computing. Okay, so now everything is serverless. So what do you mean by serverless and all? So we'll go through it. So these are all comes under 4.0, and as you can see here, cloud. So this is the industry revolution. So if you have any doubts, just please stop me at any point of time. So basically, so just we'll give a clear, I mean, some highlights about the cloud. Evolution of cloud, it started with the cluster computing, grid computing, utility computing, SOA, that is system oriented architecture. So there is a transition from architecture. As I said, initially we started with monolithic, then this came service oriented architecture, in which there is the enterprise service bus. I think we might have studied core bar architecture in the systems, in the networks. So that with the SOA, that is system oriented architecture, in which there will be integrating components. When I say integrating components, so when you book a ticket, so after selecting a seat and all, when you say payment option, it will redirect to some other service, right? Like CC Avenue, PayPal, etc. So that is a third party application integrated with Redbus, or third party application integrated with VRL, or third party application integrated with IRCTC. So those two applications are totally different, connected by service bus. Okay, so that service bus acts as a common middleware or a common platform which connects east north applications and south applications, means northbound and southbound. So northbound here it will be like whichever the booking site you refer, it may be a Redbus or VRL. The left and the right hand side is the payment option or the payment gateway. So again, once the payment is done, again it will say, right, don't refresh, it will redirect to the main page or the previous page within few seconds. So that is supported by service oriented architecture. Now service oriented architecture is again evolved by microservice oriented architecture. So that's why now in nowadays you take any application, it may be a Swiggy, Zomato, Amazon app, whatever. So everything is made up of service oriented, microservice oriented architecture, which is the extension of SOA. Then cloud computing. So now I mean, now I don't go much into the cloud, but we'll only speak about the IoT and edge capabilities from the cloud perspective. Are you all following, or am I going very fast? It's fine. Okay. So this is just a one highlighter. What happens in a minute while we are connected? Everybody is connected, right? So everybody uses phone, everybody uses a smartphone, and everybody connected with different accounts, right? Snapchat, LinkedIn, Amazon, Google, Facebook. See, there are so many applications here. WhatsApp, Instagram. So there is so many, Twitter. So there are many applications are already connected, and we have, see here, there are 1286 Netflix hours of videos streamed every minute. Amazon ships 35 items. So with just 1 minute, there are so many things are happened when we are connected. Means while we are connected, it may be with IoT or it may be without IoT or directly connection, whatever. So everything it generates for every minute. These many things are generated. So if these many things are generated, where they are stored? Somebody has to store, right? So Twitter has some backup. Like for example, KLE College, this has data is there. Data is stored in separate data center. It might be in the on-premises. When I say on-premise, the local data center available in the institute. So similarly, each application have their own data centers, or they will be having a tie-up with the cloud consumers, sorry, cloud providers. So in that perspective, where the entire data should be stored. Okay, there are so many data generated within a span of 1 minute. So every minute that much amount of data is being generated from different applications. Okay, consider there are so many IoT applications, sorry, IoT devices are connected. It may be a sensor, it may be some other tool, it may be a smart city sensor, it may be a smart healthcare sensors. So many vast amount of data is being generated, and it keep on generating whenever it is on. And there is CCTV camera also, right? There are CCTV cameras, motion detection cameras. So whenever that is also a part of IoT, because whenever there is a motion detection is happened, that particular frame has been sent from that particular location, that IoT device, to a central storage or some central unit, and from there you will access it. So again, data storage is the first option, sorry, first procedure. Second is what you do with the data. That comes in second item. Second item is divided into multiple fields. So it may be a data analytics, data mining, use AI to focus what happens next. So that is all comes once you have the data. But we'll not speak about the data, what you will do with the data, but we'll say how the data is stored and how the IoT devices and the IoT applications can be deployed on the cloud, and how they are useful, and what technology and services are being used from the cloud's perspective. So with this is a cloud definition. Cloud is an elastic execution environment of resources involving multiple stakeholders and providing a metered service at multiple granularities for a specified level of quality of service. So this is a technical definition, and as you can see, there are features, types, modes, locality, benefits, etc. Okay, so most of you know cloud means there is compute and all. So today we'll see what actually the cloud is, what actually the current cloud is. So this definition is very old. I mean, when I was studying my PhD, that is also definition is same. Now also definition is same. There is no change in the definition, but how we are using the cloud is being tremendously changed. So while I was doing my PhD, the cloud was totally different. There were only few services, and now today still I'm working in the cloud, but there are so many services are added. Even I don't know. There might be a new service added yesterday, so that even I need to go through it. So that is so much vast amount of services are being added to the cloud environment. Okay, so I will not spend on much on this slide. So this is different services like software as a service, platform as a service, and infra as a service. So having said that, with this knowledge, like it has multiple modes, types, features, benefits. Can anybody say, or can anybody guess what are the different components and services are available from cloud? From storage, network, analytics, yes. Any other things? Because earlier when the cloud started, there was only compute. When I say compute, it is only a physical systems, or it may be a virtual machines, and different types of virtual machines and etc. That was the main agenda of starting as a cloud. But now there were three modes, like we saw that software as a service, platform as a service, and infra as a service. But now this is not the true. That is, those are the three old services. But now this is totally changed now. Can anybody guess still what all other services we can have in the current cloud? Any guesses? We'll have an interaction session, okay? So I won't be. It will be a full duplex. Students might be knowing what is full duplex, right? What is full duplex? Yeah, you know that what full duplex. So we'll have full duplex communication. Okay. Components and services from cloud. Any clues? I mean, side networking, AI, analytics, compute, storage. So what are the other services might be possible? How many of you work on the AI related things? Machine learning? Anybody? Anyone works on the machine learning, AI? Yeah. So for that also there are so many tools already present in the cloud. There might from the Amazon, there is Amazon SageMaker. So there are many things. So with that, see here. So this is called cloud capability canvas. Okay. So I'll some of you said like networking, storage, compute services. So in that, as you can see, a networking, virtual networking, hybrid connectivity, dedicated connectivity. So these are all services. Each vertical comes with a heading and it has all these services: compute service, database service, enterprise integration, security, management automation. So initially, when the cloud started, there is only the third column, compute services, and there are some networking and database. But now, see, as you can see here, this columns goes on increasing day by day. See, there is one called last but one, IoT, VR and AR services like IoT Edge, IoT Gateway, IoT Events, Virtual Augmented Reality. So these comes under the IoT. That's the virtual reality and augmented reality, VR and AR, along with IoT. So IoT combines with these services in any cloud. So this is a cloud capability canvas for any cloud. I'm not speaking about a particular cloud. I'm speaking about the generic cloud. Okay. So now coming to Amazon Web Services as an example. So we'll forget about all these things. So we'll speak only about the IoT. See, as you can see here, there is the green grass, IoT device management, IoT core, and Sumerian. So there were, I think there might be some more addition also. Uh, Greengrass Core is a tool or a platform from AWS. Okay, so those who are working in IoT or those who want to pursue research in IoT, you can. I will tell you what is Greengrass Core. So you can explore the Greengrass, and Greengrass makes a platform which will connect all the IoT devices. For example, you are working on IoT project, making a campus as a full smart campus. So to make a smart campus, you need a IoT devices which will be spanned across your entire area. It may be in the gate, whatever. Consider, for example, there are 10 IoT devices which are spanned across the KLE college. Then you will gather the data. Then you will do whatever you want to do to become more smart campus. Okay, and those entire IoT devices can be connected using Greengrass core from the AWS. So once they are connected, even the connection is lost, then there is no harm. So all the data will be synced to each other, and you will get the data in one single node. So it helps in connecting all the IoT devices. So this is generic one. Today we'll be speaking only about the platforms and the services in which the cloud offers for IoT and edge capability. So these platforms and technologies can be applied for any application, any IoT application. Okay, are you all following? Yeah. So this is the components of IoT, and with that we need to also think about if this is IoT, then how the data is generated. Okay, so there are many other things. There are few things that we need to understand that we will go with one by one, and there are few services that we will come back and we'll see how these are all connected and how it will helpful for making IoT is an enabler and fast services. Okay, and this one is Azure. So as you can see here, again the headings will remain the same for all the verticals because these are services and these are the different components under them. So it's for IoT in cloud Azure. So if you want to go for Azure, if you want to use Azure cloud, so there is IoT Edge, IoT Hub, and there is IoT Hub extended, and these are yet to come actually. I think this already has been added, but these are again depends on the cloud. But the process and the procedure will be similar. You to take any cloud, but only this operational wise there will be some changes. So somebody are familiar with the Amazon cloud, so they can go for Amazon. Somebody are familiar with Azure cloud, they can go for Azure cloud. But the intention, the background procedure will remain the same for any technology. Similarly, this is Google Cloud. As you can see here, IoT Core, IoT Core. So here they speak about IoT Core. They will say IoT Hub in Azure and Greengrass Core in AWS. So the nomenclature changes, but all the capabilities, more or less, it is same. Okay. So any questions till now? How many of your research scholars doing PhD? Okay. So these services, what we are speaking, can be applied to any research field, not only particular to IoT, but we are focusing on IoT. But the other forms like lambdas, serverless computing capabilities can be applied to any field, so that you can use this as a platform to host your applications or experiment your ideas and all the capabilities. Okay. So focusing on the main IoT, so I think we all see that what is Internet of Things. Internet connects all the people, so it is called the Internet of People, and IoT connects all the things, so it is called Internet of Things. So people are connected to the devices, and devices are also connected to the people through a via medium called Internet. Then this is the best example, as you can see here. The beauty of IoT comes from this picture actually. So there is a factory, and this vehicle is coming from factory to the retail market, and they have to maintain a temperature, humidity. Earlier days, when there was no IoT was enabled or IoT was there, there has to be some temperature, and they have to keep in that particular temperature, and they have to go. But now we can have the live view of what's happening in the sensor or what's happening in that particular area. So this is just an example, but similar thing can be applied in the war field, in the defense. So without any human intervention, we can all manage the needed requirements. Here it is only with respect to temperature, but there it may be with respect to human detection, or it may be a birth detection or any external agent detection. So that comes with the IoT capability, and those interconnection protocols connecting from IoT devices to the nearby edge server. Okay, so there is a difference between edge server and the cloud server. So when you say edge server, so the computation happens at the edge. So at the edge means what? Nearest to the IoT location, or nearest to the IoT devices location. For example, a car is moving from Chikkodi to Belgaum, for example. So cloud is Amazon cloud. For example, I am using the backend cloud. So the cloud data center in the India, it is sitting in Chennai. So I can't send data from Chikkodi to Chennai to process data and come back here so that it will take action. So there will be edge servers implemented or deployed along the road from Chikkodi to Belgaum. For example, one in starting from Chikkodi and one in next location and next location. And there are few servers, so that they will communicate with nearby edge, and they will get a response. Then the entire data is backed up in the cloud. So this is how it works in the real-time scenario. Okay, we'll go with an example. So that is just how the data and the execution flow. So this is one example, so that it will be coming to the warehouse, and always the temperature is maintained, and sensor data collect and transfer. So if it is any change in the there, then there will be a communication to the nearby edge server, so that again the temperature will be set automatically. So this is just one example how the IoT works. So there are some characteristics when IoT can be applied. Okay, so the major one is event driven. Okay, when you take any application from IoT, it should be event driven, or any particular execution happens. Okay, then there will be a event. So when there is the event, then it should trigger. Okay, the best example is one layman example. You take a photo. I mean, everybody we take a photo, right? We take a photo on our phone, and if it is not good, we apply filters, right? How many of you apply filters? Some of you apply filters, right? Okay, so we apply filters and we'll save it. Okay, if you want to make it automate, what we have to do? For example, I'm telling, I will take a photo, I will upload into the cloud. For example, cloud image in a database. Okay, so I will write an algorithm. Whenever there is a upload in the database, whenever there is a upload in the database of any image, it should apply the filter. Apply the filter means what? The algorithm has filters, all the filters. It will apply those filters on that image. Okay, so that should be automated. So when it has to execute whenever there is an update in the database. So what is the update? When you take a photo. So when you take a photo, it will be reflected in the database. It will directly go to your media, right? Media files. Consider media file is a database. Whenever there is a photo update in the media files, that particular algorithm should apply. So that is called event. One of the event. Okay, one of the events. So that event is nothing but applying those filters on the data and again save back to the media files. So if you want to make it in the cloud, so I will send that data or the image to the Amazon. So when I say Amazon, there is a different database services again. So there is S3 bucket, we call it as S3 bucket, which will store any type of data. It may be a SQL or NoSQL. Similarly, there are many other things. So considering an example, I will store in the S3 bucket, then that particular algorithm will apply. So what is that algorithm? Algorithm is to apply the filters. How it will do? That is the event driven. Okay, event driven. And nowadays, for any IoT application, okay, for any IoT application, when you use the cloud or when you use any other things, any other standalone system also, there is a service called function as a service. Okay, I'll just write it down. It's very important from IoT perspective. This is called function as a service. So that is the capability from serverless computing. Okay, can anybody answer what is serverless computing? Physically, yeah. But who will do that? Next question. As serverless computing says, there is no need of server, that we agree, but somebody has to execute, right? So there is a relation between event driven function as a service with this IoT. So when you take any IoT application or any IoT service or a component or a problem statement or a complete full package or IoT package, I can say. So there will be events. Okay, when I say IoT, there will be event, right? When you say IoT, there will be data gathering, there will be event occurring. Then you have to take some action. For example, in the smart healthcare, if the aged people is fell down, so somebody has to take action, right? I mean, there is an event, we have to take action. Similarly, in the autonomous car, so car is moving from A to B. If somebody comes, I mean, if some, it has to apply the brake. For example, it may be a speed breakers or somebody comes in the on the way, so it has to apply the brake. So data is there with the IoT capabilities, but some action has to be taken as a action for that event. That event is, here the event is taking a photo. Whenever there is update in the photo, apply the filters. So these capabilities, function as a service, if you do it um, at a steady state. For example, if I want to have this as a continuous thing, we have to allocate some resource, right? We have to allocate some virtual machine. For example, this code, whatever I said, that update filters. If I want to make this algorithm to run on a particular machine, I need to dedicate one node. For example, node 1 is one PC, okay, or one virtual machine. So one virtual machine I will allocate, okay, so to execute only one algorithm or one particular code. So similarly, there are many IoT devices. I have to allocate number of devices. So it's a wastage of resources and also wastage of it's a what we can say unutilized resources are there. So because this VM can accommodate many other, for example, it is 2 CPU and 4 GB of RAM. So it can do many other things other than executing one simple program. So if I allocate this one to do this particular functionality, it is a waste, because similarly there are so many IoT applications you do. I mean, only from my side it is one. Many people will be working on so many things. So everybody allocates so many nodes. It's a wastage of resources. So thus comes the serverless capability. So there is a relation between serverless capability and function as a service. Okay. So this is backed up by, initially these are all backed up by virtual machine. When the cloud or IoT started, so it is only VM. Okay, virtual machines in the cloud. And this is mainly a monolithic architecture. Initially, I'm just teaching all the points which we covered from the beginning with respect to architecture, with respect to platform, with respect to current technology trend. Whether you use for IoT or whether it's for other service, it is same. Okay. Now, again it is cloud. Here it is monolithic, slowly changed to which one? SOA as we speak. Then SOA slowly started to improvise to microservice oriented architecture. Sorry for my handwriting, it's not good. and board is also working with me. So, so initially it is monolithic, then SOA, then microservice oriented architecture. Here cloud remains the same. Here it is VM. Can anybody guess what is there now? Here, I said initially whenever we say cloud, it is VM, then cloud, then there was monolithic architecture. Initially, monolithic architecture, which is 25, 30 years back. Slowly we have service oriented architecture. It remains the same. Now we have most of the applications are microservice oriented architecture and backed up by cloud. So where the functionality of the VM is replaced by one component. What is that component? Can anybody guess? Functionality of VM has been replaced now. VM is there. On top of that, we apply one component which is helpful to manage the microservice oriented architecture and makes things faster. Yes, it's container. How many of you know what is container? This is now container. So the basic difference is VM is virtualized of the machine, but container is virtualization of the operating system. The container is virtualization or virtual thing of operating. It virtualizes the inherent or the underlying operating system. So if you take a Windows, so there will be a Windows container, there will be a different types of containers are there. So it is the OS level virtualization, which is the container. So when I say function as a service, so whenever there is an event, the container is created automatically. When I say automatically, so there is a code, okay, which will does the filtering, apply filter, okay, filter. So this code, whenever there is a upload in the your media files, whenever there is upload of the image, automatically it will create a container. For example, C is a container, okay. What do you mean by container? It is OS level virtualization. Whenever there is an event, this function as a service helps in creating a container. This container applies this code on this image. Its work is only this much. Use this code, apply on this image, and output will be filtered image, go back to the media files, and this container is done. This container is deleted. So this container has a lifespan of only few minutes or few seconds until this particular code is applied on this image, and this container does the work of this particular VM. So it is used only for 10 seconds. For example, this is worked only for 10 seconds, and it varies 10 seconds, 20 seconds or 1 minute. So considering 10 seconds, so this container is used only for 10 seconds, and your resources are consumed only 10 seconds for 2 GB of 2 VCP and 4 GB, for example. So it doesn't take much. So it will take only few things. From 2 GB and 2 CPU and 4 GB, you can create more than 100 plus containers. So it is only one container which is ran only for 10 seconds, and it does the work, and you got the filtered image in your media files. Okay, this is the beauty of container. And this all computing is called, what type of computing is it is called? Serverless computing. Serverless. Why serverless? There is no server attached to this container. It is done automatically whenever there is a event occurs. And what is the event? Update of the, making a filtered image whenever there is a update in the image, and this function is called function as a service. And this function as a service are enabled in the cloud with different names. Okay, in the AWS, this function as a service acts as Lambda functions. In IoT, these Azure functions. So all these function as a service work on all these events using microservice oriented architecture, and backend they will create a container to execute this particular event. Okay, the event may come from any IoT device, or event may come from triggering any particular event or triggering of any particular application, or from any IoT device. So when you use IoT devices or when you see IoT applications, there will be a data and there will be events. So when there is an event, you have to take action. So who will take action? we have to take action, but in the form of code, what we want to reply. But those codes can be written as a lambda functions, and those lambda functions at the backend work using container. So now what all and I mean all interconnected IoTs, event driven architecture, event driven fields, then microservice oriented architecture, backend by cloud, performed by container with a serverless capability. Hope it is clear. I'll pause for a while. Then if you have any questions, then we can discuss. Hope I didn't go very fast, right? Is it clear? Any doubts? Are you all following, right? Yes or no? Any questions? No questions? Okay. So the major thing from any IoT capabilities or any IoT project, it is event driven. Okay, there has to be event, then only we need to take action, and the action part is this entire thing. These things. If you perform in the cloud or if you perform in the standalone computer, the procedure remains the same, only the nomenclature will be different. Here I can say instead of lambda function I will use some other OpenWhisk functions. OpenWhisk is a open source platform for function as a service capability. So I will use OpenWhisk platforms for instead of lambda functions. Okay. Then instead of cloud I will use my own PC. Instead of microservice architecture I will use the same architecture, but instead of here container I will use Docker. What is the example of container? We can create a containers using Docker, or we can create using Linux containers, LXC containers. So Docker is a platform which will helpful in creating a containers. Okay. So what is the difference between Docker and Kubernetes? Anyone? Kubernetes is helpful, but there is a difference between Docker and Kubernetes. Both are not same. When you say give example for container, then we can say Docker. Docker is not a container. Actually, Docker helps in creating a container. So Kubernetes is somewhat different. Can anybody answer? What is the difference between basic difference between container and Kubernetes, or Docker and the Kubernetes? Mainly for students, when you say, I mean in the campus, when they ask what is container, then don't say Kubernetes. Kubernetes is not a container. It's a wrong answer. Container is Docker. Docker is container, okay, but Kubernetes is it's called orchestrator for containers. Okay, so when there are huge number of containers are developed, for example, thousands of containers are developed, or if I for my project if I use thousands of containers, somebody has to manage it, right? For example, one container fails. Okay, some container may work for half time and it may fail again, or it is deliberately failing again and again. So what you should do, somebody has to take care, right? So if I have only 10 containers, then I can manage, or one system admin can manage. If there are thousands of containers, how you can manage? So there has to be some orchestrator. So when I say orchestration, it's automatically managing all the containers. So that is done by Kubernetes. Kubernetes is helpful in managing all the containers. So Kubernetes is it's also it's a project from CNCF, okay, Cloud Computing Computing Nation. So this is an open source platform. I will share that link actually, so it's helpful for everyone. So which has all the open source projects across the globe. Okay, so that is the child of that particular CNCF community. Okay, CNCF community has given lot of projects, lots of not projects, lot of technology platforms to the humankind. So Kubernetes is from there. There is some Istio. There are so many things. So all those are derived from CNCF community. So it's an open source platform. So as a researcher, as an academician, as an industrialist, everybody should contribute, or else we can use all the open source platforms. So it has different categories like what we have mentioned here: networking, orchestration, database, so everything. So MongoDB is from this one, Kubernetes is from same one, and nowadays in the industry we are following the practice called DevOps, development and operations. So DevOps, there is a different tools called uh, CI/CD pipelines. Yeah, CI/CD pipelines. So there are many tools for CI/CD: Travis, Jenkins, etc. So those are all derived from CNCF. So I will go share that link. So when if we have time, then please go through it. It's very helpful so that you will get an idea what are the different current technology platforms are available in the market. You can also contribute. So that is the opportunity. If you are interested, you can also contribute to that particular community. That is called CNCF community. Okay, or you can in the Google you just say CNCF landscape. If the first link itself, you will get it. CNCF landscape. Okay. So ambient intelligence. So again, with the event driven, ambient intelligence means when the action should take. So there are so many data generated whether the action is should take for every event or not. Then flexible structure, semantic sharing, complex access technology. So these are all the second level and third level characteristics I can say for any IoT application or a project. So the basic one is event driven. How the IoT works, as we all know, there are sensors or actuators for any application. It may be autonomous car, it may be smart health, smart city, whatever. Then there is a connectivity from IoT devices to the nearby edge locations and the cloud. Okay, people and process. So how they are connected? They are connected with the process. The process is nothing but this one, because we are for any event we are performing this particular action. People means whom they are connected. For example, people are always not a part of the process number 3. Always process is mandatory. People sometimes they are involved, sometimes they are not involved. Okay, so these are the 3 major things which will happen or which should be continued, which should be applicable or for any IoT applications or projects. Then these are some sensors. I'm just giving the different sensors. I think somebody just might have covered in the previous lectures as well, like water sensing, water leakages, flow, gas leakage, acoustics, humidity, temperature. So these are all different IoT devices and different IoT capabilities which will be helpful for sensing and then transfer. This is only sense. There are 3 steps, right? Sensing, connectivity, people and process. Sense means just sense it, get the data and connect to the nearby one and process it. Process is nothing but this action. Okay. So edge means executing at the nearby edge location, nearest to the IoT capability or IoT device. Cloud is nothing but it is at the back end. So all these 3 are interconnected. Okay. In the case study, you will understand what is the clarity differentiation between the edge and the cloud. So these are the different sensors. Connectivity. So connectivity again ranges. So if I have the IoT project only in this room, I can connect through different capability like different Bluetooth or different Zigbee protocols, etc. Or through Wi-Fi if it is through if it is through entire campus. But if I want to drive from, like for example, Chikkodi to Belgaum, uh, without the driver, I mean the autonomous car should go from point A to point B without a driver, then you would say span across kilometers, right? So that time how we will do? So it should be connected to the 5G or the nearby mobile towers, which should be connected. The nearby edge server should be connected to the nearby towers. That tower again in turn connected to the cloud. So there should be a minimum delay or minimum latency, I can say, for any particular action and reaction or any event and the action. So those all comes into picture when you make a real-time IoT capability project for a large scale scenario. Example is autonomous cars, because it has to drive from point A to point B, and the complexity involved is depends upon the number of kilometers or the distance between point A to point B. Or if I want to implement IoT project within this campus or within this small project, those complexities are different. How many of you used Arduinos or Raspberry Pi devices? So these are all very, I mean, easy to understand and do the experimentation at the, at the college level, so that we can have different Arduinos and different. There are some their devices actually I forgot, and Raspberry Pi devices mainly. So those can act as the similar structure, but in a small scale. and these are the people and process. Again, it is involved in, I mean, this is the higher level, I can say front end. So control and automation, remote sensing, analytics and cloud API, location tracking, financial services. These are all process, but these are the customer. I mean, these are all different departments, I can say, in which these things can be interrelated or interconnected, the people and the process. So these three are mainly done. I mean, mainly focusing on the IoT. How IoT works for any type of project. Okay. Okay. Any doubts? So as I said, initially we started with this simple monolithic architecture. Then again we are now in the microservice architecture. So there is a limitation of three-tier and monolithic architecture. When I say three-tier, front end, back end, and the I mean database and the middleware. Front end, middleware, and the back end. Okay. So these were some you can say major drawbacks when you say monolithic architecture, and nowadays you won't feel that. Okay. So when I was studying in VTU, then whenever I get result, whenever I put my USN number, I used to get my result after half an hour. What was the difference? I mean, now it will not happen, right? I mean, now you will get it within seconds or within few seconds. Difference that time even I was not knowing, but now we got to know that there is a load actually. So there is a capacity of each VM at the back end in which it can serve how many number of people. Okay. Nowadays in the Amazon app, for example, everybody uses Amazon app during the big million day, right? That time, is there a delay in the app service? No, right? There is no delay in the app service. And even if you, I mean, access it now also without the big million day, that's also same. But during big billion day, the number of users are huge. You can't predict actually. It will be a number in maybe in crores, because out of 135 crores Indian population, it will be minimum crore for India. So during the non-big million day, then it will be like in thousands or in lakhs. So, but the performance remains the same. So, what is the reason? But if there is the same case with the video which I said, it should be hanging and I am not able to access the app. So, the major difference is it is using the microservice oriented architecture, because the backend is container. Now there is no VM. There are VMs actually. On top of VMs, containers are being done. Okay. So exactly, I mean, how that particular work is done. So when you say, we'll just give a brief abstract of how it works and why it is not delayed, and similarly those similar structure is applied in the IoT one, and that is a major drift between monolithic architecture to microservice oriented architecture. So when you say app, when I want to whenever we log into the Amazon app, what are the major services we use? What are the major services we use? What are the major services? No, no, not cloud is fine. I mean, what are the major when you want to buy anything from the Amazon app? What are the steps we follow? First, we log in, right? First login, then search. I mean, I'm just taking a few process, not entire thing. The basic one, which will complete all the buying a product, for example. Login, search, add it to the cart, buy. These four are minimum requirements. Okay. So when I say login, search, cart, buy, or payment. Okay, so these are the four process we need to follow to buy any particular product. Okay, for example, this has been hosted in the VM fashion, VM1, VM2, VM3. Okay, which can accommodate 100 people. VM1 can accommodate 100 people, VM2 can accommodate 100 people, VM3 can accommodate 100 people. So this is the steps we need to follow, and consider this is a regular day and I will be logging and only 200 people are logged in and there is no hang in the machine. Consider this is a big million day, 500 people are logging. What we need to do? Now it will, with this infra, it will hang, right? Definitely for 300 people it will give service. For the next 200 it will not work properly, right? Because of the the resources are unavailable to allocate or to provide service to these 200 people. So what we can do? What is the solution? Distribute the load by adding the VMs. Okay, so I will say I will add VM4, VM5 in the VM4 and VM5 in the given infra. This is called infrastructure. Okay, infrastructure as a service. So VM4 and VM5 nowadays it can be added automatically in the cloud depending upon the load. So initially there was a load prediction, and depending upon the load prediction we used to allocate the resources. But with the help of cloud capabilities, without any demanding about, without any checking on the load, so whenever there is a load, more load, the resource will be expanded, and whenever there is less load, resource will be degraded. So that capability is called auto scaling. Okay, auto scaling capability in the cloud. So this is called auto scaling. Okay, auto scaling. This is called horizontal scaling because we are scaling the similar set of VMs in the horizontal manner. Okay, and we have the, if you know the load already, then we can have vertical scaling. Means, okay, for the KLE college only 1000 people can access. For that I can have only 100 GB of RAM and 500 CPU. That is enough. So I will allocate only one data center which can accommodate 1000 people, because this 1000 will never increase, right? For KLE college, this 1000 will never increase. So we know what is the load and I will fix the load. This is called vertical scaling if you want to increase here. But here we don't know. Sometimes only 100 people will be used, then only VM1 will be used, then VM2, 3, 4, 5 will be deleted. And if there are 500 people, this will be there. Okay. Do you feel still is there any loss of or resources are being underutilized? So when I say if there are 300 people, 3 VMs are there, then it is fine. During a big million day, 500 people, 200 people or more, then the solution is add VM4, VM5 so that it can accommodate 500 people. I say this is not the, this is the solution, but resources are being underutilized. How? This is a solution. Okay, I agree, because we added 5 virtual machines, it can accommodate 500 people, that's fine. But still, this solution is not efficient. Still, it can be optimized. Can any answer? Any guesses? How? Yeah, correct. You are 50%. You are right. On the similar lines, it is. Did anybody get what he said? He is saying somebody will come, somebody will use services, and he will leave. But there is some room for improvement to allocate that particular space. Am I right? You are saying that one. Okay. So in the similar lines, think about this one. 1, 2, 3, 4. During big million day or any day, how many of you logged into the application, searched for item, added to the cart, made a payment, and bought the item at one go? How many of you? I didn't do at any time. Did you get my question? At one go, did you buy any item in Amazon? At one go, without going previous back. Go log in, search for iPhone 15, add it to the cart, buy. Did anybody bought this? Not iPhone 15, any item. No, right? You will wait for some time, the price may decrease and all. So some people are hanged in login page out of 500. Some people are hanged in search page out of 500. Some people are in cart. Some people are in payment gateway. So what it does it mean? Out of 500, you think how many people will use all these services, all these 4 services at one go? 10%? Max 10%, not more than that. So what is the 10% of 500? 50, right? Only 50 people are using all these 1, 2, 3, 4 services at one go allocated on these machines. What it means? So these 5 virtual machines has a capability to serve 500 people, but only 50 people are used it efficiently. Remaining 450 people, somebody people will log in and they will keep as it is and they will go. I mean they will search later after 4 hours. Some people will search and they will leave. Some people add 4 items to the cart, they will never buy. Some people will buy after 2 days. Only few people, that is 10%, this is also max actually, so I just consider 10%, who will do all these 4 services at one go. So in practical, only 50 people are utilizing all these services. Remaining 450 people are hanging in all these services, which can be accommodated only with 2 machines. Okay, because 2 machines are enough to log in, to search, or to add it to the cart. The remaining machines are not required. So all these 500 people, whatever they are doing, they can be accommodated with 200, sorry, with 2 VMs only by discarding VM 3, 4 and 5. As in practical I am telling. Are you following? Because the services are not used efficiently. In reality, it has a capability to perform 500 people if they do all these activities. But they are not doing activities, right? Only 50% are people doing all these activities. Remaining 450 are underlying, are not using all these capabilities. It means that these VMs are not using efficiently. Are you all following? These VMs are not using efficiently. So what I will do, I will create a container. So here comes the microservice oriented architecture. So I will create for one login, for any one login, I will create C login, means container login, container search, container cart, container payment. So these are different types of containers. Whenever people log in with this container. So after login, successful login, the container associated with them will be deleted. Again, they will switch to second container. Second container will search, then again third container will add them to help in the adding it to the cart. Then fourth one help them to making a payment and buy the device. So these 4 containers will help for one person, and these 4 containers are running in parallel, or sometimes this will be deleted, this will be active, this will be active, this will be deleted, this will be active, this will be deleted. So it means that at any point of time, only 1 or 2 containers are active for one person. Okay, and for 500 people, considering 2 containers are required. So how many containers are required? 1000 containers are enough to accommodate all these 500 people. And these machines, for example 2 CPU and 4 GB of RAM, can accommodate 500 containers, for example. And with 1000 containers, I can need only 2 machines, so I can delete all these 3, 4, 5. So with only 2 VMs with microservice oriented architecture, I can accommodate 500 people, but which is not same with a virtual machine technology, or when you use only virtual machines. But if you use virtual containers on top of the virtual machines, you can accommodate same load for the same applications using 2 virtual machines rather than 5 virtual machines in the only VM methodology. So that is the beauty of containers and microservice oriented architecture. Did you all follow this, or any doubts to this? This is a bit confusing at first time. If any doubts, please ask. So this is how the Amazon app works. Similarly, all the dynamic applications, it may be a Suki or whatever. So this is how we should be, so that we can utilize the resources as efficiently as possible. So with that, so these are the drawbacks: non-responsive UI, monolithic code base, legacy database, software complexity, lack of modularity. So these are all addressed by this particular architecture. So when you see the applications just 10 years back and the current applications in the mobile, do you feel the difference, right, with respect to UI, UX, user interface, user experience? And it is so easy to understand and is easily accessible, right? Always UI, UX should be very much important. So these are all the drawbacks of monolithic, which are overcome by microservice oriented architecture. And to do that, for any IoT device or for any edge device, the backend is container. Now the future of cloud is container and Kubernetes. So who are working in the cloud area, we should not be restricted only to the cloud, because cloud runs, cloud is a backend, which cloud is a backed up actually. So the main drivers will be containers. So containers means when you say Dockers and more number of containers, it is Kubernetes, because Kubernetes has to apply on top of the containers to manage and orchestrate. So now the cloud means containers. So that capability is called now cloud computing. I can redefine it as serverless computing. It's not only cloud, it's serverless cloud now, because everything is serverless, because there is a VM, but we are not using actual VM. We are using the containers on top of the VMs or on top of the bare metals. Okay. So this is, and this leads to whatever we said or we spoke, this leads to application modernization. So this is called application modernization. Okay. I think some of you are maybe having the SBI bank app, right? SBI Lite. So when you think about that application itself, before 5 years, the application was not user friendly. Now it is very user friendly. Even without, if you know English, if anybody knows English, he can operate that particular app, the banking app, mainly the SBI. Why I am quoting SBI? It has been tremendous improvement happened compared to the last edition before 5 years, with my experience. So why it is happening? Because of application modernization, and there is no lag and all. So this all comes with the involvement and improvement in the technology and trends. And what are those technology trends? It's IoT, edge, backed up by action items, executed by function as a service. Okay, so that is called serverless capability. And this is just an why it is important: application modernization, cost savings, operational resilience, risk mitigation, automation will happening. So these are all IT efficiency. And again it comes to business efficiency, because when you have faster growth and faster to market, then the business will be grown. That is a increased revenue and speed to market, etc. So these are all different angles with respect to business and IT efficiency. uh, this is not so important. So modernizing the how we can balance actually. So there are rehost, replatform. So there is an improvement, or there is an who are working in the cloud area. So there is a huge opportunity to work on the migration. Okay? We are all migrating from on-premises to cloud, we say. So we are migrating. The company is migrating to cloud. So what do you mean by migrating to cloud? You are shifting all these services and resources from your on-premises. When I say on-premise, you have a data center in your location. It may be a college, or it may be institute, or it may be a company. You are moving to the cloud. So when you move to the cloud, there are so many things changes. So many things changes will happen, and so many changes you have to make. So that is called migration. So sometimes you have the VMs, and now the technology is virtual machine, right? Sorry, container. So I need to move from virtual machines to container. So that is called refactor. Factor means you are refactoring from virtual machine to container. Sometimes it is called lift and shift, means as it is lift and shift. So we have VM, I need VM in the cloud also. So that depends upon the business requirement, and how you want to show yourself, or how you want to see yourself or company after 5 years. So that is the business angle, and there are many things. So that this slide speaks about those things. Okay, and just I will have a few more minutes. Yeah. So I will have 10 more minutes to wind up. So this is, we mainly speak about edge computing network, right? So it mainly consists of edge service layer, edge computing layer, and cloud computing layer. So as you can see here, this is the device layer. So when I say device layer, it may be actual sensors. Again, the same three principles: sensors, controllers, or actuators. This is the edge layer, in which the actual capability happens nearby the servers or nearby the IoT machines than the cloud. So cloud will be like at the back end to process the data. So mainly the cloud is helpful in this particular architecture to mine the data and again use that data for some other things. So when you say mine the data, so can you give me one example? What is the mining of data using IoT devices? What is the mining of data and what is the very nearest example to everyone? So if we everyone witnessed that, can you give me that example? Everyone, including me, everyone witnessed that example. That what do you mean by data mining and what do you I mean mainly the usefulness of that data? How do they mine the data and what is the best example? Yeah, web mining, that's fine. That they do web mining only, but what is the real time example that everybody witnessed? Yeah, yeah, correct. But can you give me one example? Example. Yeah, you both are right, but I need one example so that everybody will understand with that example. Everybody uses Facebook, right? Everybody uses YouTube, right? Not Facebook, YouTube. So when you open your YouTube page, when I open your YouTube page, is it same? Why? And how it matters? As per their subscription is one thing, but as per their search once they logged in. It is true for YouTube, it is true for Facebook, and it is true for any application. When in the Facebook, when you see certain type of reels, you will see only those reels. You will get to tend to feel and read and see only those reels. In the YouTube, if you see only the, for example, Shivraj Kumar's videos, so whenever you open YouTube, there will be a list of Shivraj Kumar's videos only, not the others. So for some, it may be like Jackie Chan's video. So it depends upon the data and what from the profile. As you said, you are also right. You are also right. But they will integrate both the things, profile and all the search data, and they will come up with a plan. So that is a huge market now. That's why in the initial slide I had shown you in 1 minute how many amounts of data is generated from all the applications. So that is the huge enormous data which is already there, and it's being used and misused in multiple ways. It's being used and also misused. So you will get many calls, right? So your phone number is shared. Somebody, you will get calls, right, from loans, for loan calls, this call, that call, random calls you will get. I get many calls actually, but I didn't share my phone number to anyone. But somebody has already shared my phone number to all the third parties. So this is one type of leakage. So this is only with a number. There might be a leakage of Facebook. There might be a leakage of this one. That's why Facebook has come up with a lock on your profile so that you can lock only your friends can access your profile. So these are all again nuances of data. After you get the data, it's one more problem whether what to do with the data. So those are all many. There are many other things and many other research opportunities with that data. So coming back to this one, so this is architecture, and these are the few basic principles that we should follow for any edge computing architecture. That is the proximity. So always there should be proximity in terms of what you do, what you compute you do, and decentralization. So spanned across different regions with the with IoT devices and actuators. Heterogeneity, heterogeneity of the diverse range of devices and systems. That is heterogeneity. Security, security comes at different levels. We don't speak about security now because again it will be a 3 to 4 hours lecture if we speak about security, because security can be applied at different levels. It can be applied at lower level, data level, authorization, authentication, data level, and network level. So security is applied at different levels. So if we apply security at all the levels, then only you can say we are 90% or 95% secure. But only if I say, sir, I have the password and that's it, then you are fail. Password can be easily hacked or easily it can be breached. So security is again different ball game altogether. So security should be applied at all the levels, whatever, whether it is IoT device or whether it at any device. And data management involves effective control and organizational utilization of data generated and processed. So what we spoke now, so that comes under data management. So how you use the data for mining, for analytics, etc. use case, I will quickly go through this use case. This one which I worked during my postdoc. This is cloud assisted real time methods for autonomy, that is called, I mean the project name is Karma actually, cloud assisted real time methods for autonomy. So as you can see here, this is a Land Rover car, so in which there were I think 500 or I think close to 1000, I guess 1000 plus sensors were attached in the, we have removed all the seats, only the driver seat was there. All the complete setup was there, built middleware, firmware, everything was set up here. And there was an experiment to move car from 1 kilometer, like which has a circle also, from A to B, 1 kilometer. And for every 100 meters we have presented, or we have deployed a edge server, so that whenever the car pass from 0 to 100 meters, it will communicate into one edge server, considering this as the edge server. Then from 100 to 200 it will communicate to the second edge server. But these are all backed up by Amazon Cloud. So Amazon Cloud we used during this experiment, and this is a classic example of IoT, because this particular car has 1000 plus IoT devices. When I say 1000 plus IoT devices, it may communicate with all the edge servers in terms of different functionalities. Okay, think about the car is moving from A to B in the Indian roads without driver. How many actions and reactions it should take? Okay, with the driver only, it is very hard to drive in Indian roads. Without driver, it is not possible. I mean, possible, but it's very complex. So considering those things, so it is in the closed environment even though, but we have made different barriers like speed breakers, and some cows will be coming, or some different obstacles. So with that, we already witnessed what is the response time and all. So the latency should be minimum, and for that, what all we used. Okay, so whatever we spoke till now, so I wanted to keep highlight here. IoT platforms, we use Greengrass Core, IoT Hub, compute, containers and serverless capability, edge enabled protocols, fast decision making principles, and it can be a part of AI. I mean, those are working in the AI can be part of AI, and function as a service is very much important. So with that, I'll just go through one video which is Greengrass Core. I mean, I said Greengrass Core is a beautiful example platform for attaching all the IoT devices. So one is Lambda function, I mean the function as a service, and the other is Greengrass Core. It's a 2-minute video, just we will watch it. Yes.
Building applications, you want them to deliver a great experience for your users. Maybe you want your application to generate in-app purchase options during a gaming session, rapidly validate street address updates, or make image thumbnails available instantly after a user uploads photos. To make this magic happen, your application needs backend code that runs in response to events like image uploads, in-app activity, website clicks, or sensor outputs. But managing the infrastructure to host and execute backend code requires you to size, provision, and scale a bunch of servers, manage operating system updates, apply security patches, and then monitor all this infrastructure for performance and availability. Wouldn't it be nice if you could just focus on building great applications without having to spend lots of time managing servers? Introducing AWS Lambda. AWS Lambda is a compute service that runs your backend code in response to events such as object uploads to Amazon S3 buckets, updates to Amazon DynamoDB tables, data in Amazon Kinesis streams, or in-app activity. Once you upload your code to Lambda, the service handles all the capacity, scaling, patching, and administration of the infrastructure to run your code, and provides visibility into performance by publishing real-time metrics and logs to Amazon CloudWatch. All you need to do is write the code. AWS Lambda is very low cost and does not require any upfront investment. When you use AWS Lambda, you're simply charged a low fee per request and for the time your code runs, measured in increments of 100 milliseconds. Getting started with AWS Lambda is easy. There are no new languages, tools, or frameworks to learn. You can use any third-party library, even native ones. The code you run on AWS Lambda is called a Lambda function. You just upload your code as a zip file, or design it in the integrated development environment in the AWS Management Console. Or you can select from a list of function samples pre-built for common use cases such as image conversion, file compression, and change notifications. And built-in support for the AWS SDK makes it easy to call other AWS services. Once your function is loaded, you select the event source to monitor, such as an Amazon S3 bucket or Amazon DynamoDB table, and within a few seconds, Lambda will be ready to trigger your function automatically when an event occurs. With Lambda, any event can trigger your function, making it easy to build applications that respond quickly to new information. To learn more about AWS Lambda, visit our website and you can get your first Lambda function up and running with a few clicks in the AWS Management Console.
So you got the video? Am I audible? Yeah. So this is mainly what we spoke, right? So that Lambda function creates a container at the backend, irrespective of how many events it triggers or how many events it is being used. So that is the beauty of microservices and function as a service. So this is the Lambda function. So for any IoT devices, this has to be there when you use cloud. So it is with respect to AWS, but if you use any cloud like Azure, it is Azure function. Or for Google, it is Google function, and for AWS, it is Lambda function. So similarly, this is the action item when there is the event. So how to attach all the IoT devices? So that is one more platform. So in the Azure, Microsoft Azure, it is called IoT Hub, and in the AWS there are many platforms, but we'll just have a 2-minute video on the AWS Greengrass. Okay, so Greengrass, how it will helpful in attaching all the IoT devices. So in the example which in the experiment which I did, so there were so many IoT devices, right? So all were connected through AWS Greengrass core, so that everybody can come, each device can communicate with one another using the Greengrass platform. So that is the Greengrass. It's just a 2-minute video.
Building applications, you want them to deliver a great experience. Greengrass brings cloud programming and functionality to sets of IoT devices, empowering them to communicate and react when a cloud connection is not possible. These devices together are known as a Greengrass group. Groups are always defined and configured from the cloud. In this case, the group is defined around a manufacturing site. The first step in creating a new group is to establish a Greengrass core in this cloud definition. Every group needs a Greengrass core to function. Adding a core to your cloud definition of a group represents a physical device on which you'll install Greengrass core software. That core software securely connects your device to AWS. Once you've installed this software on your core device, you continue to define your group in the cloud. You can add other provisioned AWS IoT devices to your group definition or AWS Lambda functions, simple programs that can process or respond to data. Build and edit your definition safely in the cloud, and then deploy your group to make it function. Once deployed, your group's devices and programs can communicate and react even without a connection to the cloud. That's AWS Greengrass.
So this will be helpful when communicating and integrating all the IoT devices using Greengrass core, so that you will not miss any IoT device, because if there are only 4 to 5 devices, that is easily manageable. But with in the war field, or in the, for example, from autonomous car from point A to point B, there are so many IoT devices. So how you can manage in each console? That is not possible. So then that scenario, these platforms will helpful in integrating and communicating with all the IoT devices. And these are some protocols which I will not go in details. I think you will be getting it through some, next lectures and all. So these are all application layer protocols mainly used in IoT devices: MQTT, AMQP, AMQP, and COAP, DDS. So these are all different protocols that we have used, and also most of them will be using. And this is how it works actually. So there is the MQTT broker in the cloud. There is a publisher and subscriber mechanism, so that whenever there is an event occurs, the events will be publishing to the subscriber. So car will be like a publisher, and the edge device will be a subscriber, because it is subscribed to a particular event. For example, brake event or accelerator event. So whatever the events are related to those particular action, so all will be pushed to the edge server. So this is called publisher. The car is a publisher, edge device is a subscriber, and vice versa in the cloud and the edge. So each one sometimes become the subscriber and the publisher, and there will be an event occurs, and for that subject those events will be continuously triggered and continuously monitored, and for everything there is a action for a event. So that action is whatever we have spoke. So that action is acted on that car with this mechanism, whatever we have done, like containers, and with a minimum latency as much as possible. And this is one example for smart city, like smart waste management, smart citizen, outdoor parking management. So for all these are the different categories I can say from the smart city. Only the smart parking, and that's not, I mean, this is a part of smart waste management. So again, it involves all the IoT devices, whatever we spoke, but mechanism remains the same. There is the event, there is the action. So event and action are go hand in hand in IoT devices and or IoT applications, and backed up by nearby edge locations and cloud. So there are some research trends. Who are doing research. I mean recently and all. So there is a good opportunity for taking up research in digital twin. So it is just a new research field in which we do the replica of the actual environment. Okay. For example, there is a war field. I will make a simulator. We use the simulators, right? But it is the actual replication of the entire real-time field. For example, this is a lathe machine. Okay, so I can't use the lathe machine for every project, right? So it's very costly. So I will create a replica of lathe machine using a digital twin so that it will work as real as possible. So that is a called digital twin, and it comprises of these four major can say technologies: IoT, cloud, AI, and accelerated rating. So these four enables the digital twin. And these are some applications of digital twin, like build management system, fire, security, automated workflows. I mean, whatever we are using the services now, all can be applied, almost all can be applied using a digital twin. And these are some features of cloud, as we have mentioned: serverless, nano services, microservices, containers. This is Docker example, and this is Knative, service mesh, Kubernetes. So these are all five. I mean, all six I can say. These are from CNCF Foundation. Okay, just search CNCF landscape in your mobile or in your laptop. You will get the first link, CNCF landscape. So if you open that, you will get the entire history. I mean, all the CNCF community related projects. And these are some research challenges, cloud computing research challenges. This is a bit old actually, but still applies. And as I said, this is data mining, data analytics, predictive, descriptive, prescriptive, and diagnostics. So again depends on machine learning, and machine learning again depends on artificial intelligence, cognitive, deep learning. So these are all sisters and brothers. And there is a huge opportunity with infrastructure management. Those who are interested in infrastructure management, these are tools called Chef, Ansible, Puppet. So these are all tools and technologies which is helpful for automating the infra. Okay, like system admin has been removed nowadays. This is all done by these platforms. Microservices using Docker, and again it will give an answer to Kubernetes. Quantum computing, big data, blockchain, and IoT. So these are some future trends, and these are some tools to write some good research papers, like Inkscape, Draw.io to draw the images, Gnumeric is to plot the graphs, LaTeX is a tool to write the all the uh, articles, Jabref adding references, Xmind for dependency graph overview. So Xmind is free also. So this is Xmind. So this one I made it through Xmind. So this type of figures you can get in the Xmind using Xmind. And these are the some tools for writing good research paper and also plotting graphs, images to make paper more readable and more good. Okay, so with this I will stop my lecture, and happy to answer any questions. Hope I didn't bore you people, right? Any questions? Okay, if no questions, we'll wind up. Thank you.
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insights you have provided.
I would like to request Professor Vinod Biradar to present a moment or to our today's resource person, Dr. Sridhar Domnar. Thank you, sir. Now I request everyone to follow for lunch break. The next session will be conducted at 2:30.